Today, and for all those who are joining the telecon today. It's a pleasure to be here representing the Commercial Crew Program and giving you an update on where we are relative to Starliner's first flight
on the
crewed flight test.
Screen.
I will tell you that the team has made a tremendous amount. We last spoke back in early June. We've learned a lot about the various issues with the P213 tape and also the soft links on the parachutes. And I'm extremely proud of...
And in kind of presser fashion, guys, I'm going to shut up while they're talking. I like listening. It's important to listen, so because information comes at you quick, so I'm shutting up.
First of all, on the parachutes, where we had the soft link issue that we talked about last time, this particular area that didn't have the safety factor of 2.0 required for a safety critical system, that has been redesigned by the team. They're in the middle of testing of that design. They had a very productive technical interchange meeting in early July at the supplier, and not only did they redesign that particular joint, but also went through and looked at all the rest of the areas on the main canopies and the drogues and the forward heat shield parachutes and the pilot chutes, and didn't really find any other areas where we had a joint that was had improperly designed. So they went through and did a thorough review of the entire parachute system to make sure we didn't have any other areas that we would have a concern about. So that was very productive and a great technical interchange meeting. On the P213 tape, this is a tape that's widely used across the aerospace industry for many applications for protecting wires from abrasion. I would say in the NASA database, the entries in the database were a bit inconsistent relative to the flammability of that tape at various levels of oxygen concentration, and so it was a bit confusing as to when it could be used and when it couldn't. The Boeing and NASA team have worked very hard on the P213 tape, and Mark will talk more about that, but the team has actually removed a substantial amount of tape. They've broken the spacecraft into two areas, what's called the upper dome in the crew module and the lower dome beneath the floor, and they've remediated about 85% of the tape in the upper dome and have removed a substantial number of pounds of the tape actually from the vehicle, and also developed a few techniques to mitigate propagation should anything happen, and an additional tape to apply. So that has been an extremely valuable exercise and tremendously productive by the teams that have been working hard on that ever since we last talked. We've also continued to work on progress toward the crewed flight test. We are 98% complete with all the certification products for that flight, and so we've continued to bring items to the program control board and sign off on the various certification products, which has been really good. We did conduct a forward heat shield parachute overqueue test at the highest dynamic pressure that those parachutes should ever see. We did that in early June. That test was a successful test, and we have no concerns on the forward heat shield parachutes, and so that was a big activity that we were working on when we last talked, and that was completed successfully in the summer time frame. We continue to work on the software and have worked through many items in the software testing and with the crew, and that's largely behind us, so we've made a lot of progress in those areas as well. Also, as the Aerospace Safety Advisory Panel has discussed, they recommended that we have an independent team to go off and look at the issues relative to the final resolution to go work toward flight for CFT. NASA and Boeing have put in place several different layers of independent reviews to work through the issues and to make sure that we didn't have anything else out there. I'll start with Mark's team. Mark has an independent team within the company that's looking through various areas that we've closed out for flight, and they've been reviewing that, and they'll continue to do so as we move toward flight. On the NASA side, we ask our chief engineer to go off and re-interview and re-talk to every subsystem manager. The vehicle is divided into subsystems, for example, propulsion or thermal protection, or parachutes. Go interview all those subsystem managers and make sure that there's nothing else out there that we should be concerned about, and if there is, we'll elevate that and we'll go do deep dives and work those. And then finally, within NASA, we have asked the chief engineer for the agency, his deputy, and the head of the NESC to work with our technical experts and to independently review each of the major issues remaining for flight. And of course, they have an independent reporting path for the flight readiness review that will be held before the CFT flight. We did brief this plan to the Aerospace Safety Advisory Panel last week, and they were pleased with our plan of independent reviews, and they felt like this was exactly what we wanted to do on the NASA side, the Boeing side, and then as also pointed out by the Aerospace Safety Advisory Panel. So I'm super proud of the team. Overall, we're making a tremendous amount of progress toward flight. We will go fly this mission when we're ready. It's hugely important for commercial crew to bring on a second crew transportation system for the ISS program, and I know Joel will talk more about that. And with that, I'll turn it over to Mark Nappy from Boeing.
All right, thanks, Steve, and good afternoon, everybody, and thanks for joining us. Last time we talked, we let you know that we were standing down for two main items. Steve talked about them: the parachute soft link issue and the tape flammability issue. Just a reminder, the tape that we used, Steve talked about a little bit of ambiguity in the specification, and we considered the application that we had as acceptable. Later in the design process and the certification process, it was determined that tape was flammable in some of the applications that we had, so we needed to go back and revisit that. On the parachutes, we have a soft link that is the link between the main lines that come up off the capsule and then turn into the risers, where that soft link was found to have been tested incorrectly many, many years ago. And when we did test it correctly, it reduced our factor of safety, which gave us less margin than we would like from the factor of safety of 2.0. So a lot of work's been done. Both those topics are very well understood at this time, and I'll talk a little bit about what we know and what our path forward is to closure. A very impressive effort by the teams. Both sets of teams jumped on these issues very quickly and got to resolution. On the tape, we formed a joint Tiger team between us and NASA, and their job was to test and recommend remediation efforts to the production team so that we could get to work on the vehicle and clean the situation up. They took just a couple of weeks, got a lot of testing behind us that did a couple things. Number one, it told us what kind of remediation efforts we could use, and it also told us where we had applied tape and its application was okay, and we didn't need to do anything. So that effort is still ongoing, but we are working on the vehicle, and like Steve mentioned, the upper zones are complete, and the lower domes are just getting started, and those zones will be addressed over the next couple of weeks. The chute team was a joint effort between us, NASA, and Airborne, our supplier, and options for the soft links were discovered right away. It was actually a really interesting story. One of our engineers on the program builds chutes for personal use, and the day that we found out that the testing was suspect, he went home in his garage and built 3 prototypes to try and understand what we could do next, and brought those back over the weekend. We tested them, found some load instruments here at KSC and tested them, and right off the bat, we had a really good head start on figuring out what we needed to do to redesign those. So we worked those into the plan with our supplier, and really that helped contribute to the final design that's currently in work. We had a couple of technical interchange meetings with all 3 parties, and the teams have made some good decisions, and we're off implementing them now. And to talk a little bit about the details of what we're doing on the chutes, the soft link design has been modified to a stronger Kevlar wrap, and it's currently in fabrication. We made a decision to go to the next configuration parachute that was planned for PCM1. We call those our 511 chutes. As a slight improvement of additional stitching on those to a radial joint and we considered that a really good move at this point. The soft link will be incorporated into that chute, and that chute was planned to have a drop test this fall, and so we just kind of piggybacked on that drop test, and we'll just basically kill two birds with one stone here and go straight to that chute. That new parachute is the critical path, the delivery of that parachute. It's being built by Airborne as we speak, and the soft link is being incorporated into that. And we're anticipating that there's 3 chutes, and the final chute will be delivered around the beginning of December. We expect that the drop test will occur in mid to late November. That's what the planning indicates at this point, and we'll watch that closely. But again, the parachute delivery is the critical path. On tape, the team has been focused on the remediation techniques, like I talked earlier, and what kind of applications of this tape are susceptible to the propagation of flammability. And so we're applying all those remediation efforts. The vehicle's been broken up into 12 zones, as Steve said, and we're addressing each zone primarily with tape replacement. If it's easy to take it off, or if it's easy to get to, we certainly are taking it off, and we've taken off more than we expected. It comes off rather easily. And we'll continue down that path, and for some of the areas that are maybe a little more difficult to take off, we'll look at other remediation techniques such as barriers or protective coatings. We'll expect to have all those zones addressed and the vehicle into some level of regression testing by the end of September. As far as the flight readiness and launch readiness, the chutes, like I said, will drive the readiness for potential launch dates. And right now, based on the current plans, we're anticipating that we're going to be ready with the spacecraft in early March. That does not mean that we have a launch date in early March. That means that we are ready with the spacecraft then. We're now working with NASA Commercial Crew Program, ISS, and ULA on potential launch dates based on our readiness. It's a complicated manifest on ISS, as you all know, and the launch pad of ULA, so we'll work that throughout the next several weeks and see where we can get fit in, and then we'll set a launch date. Of course, we have other areas that we're working in parallel with all this. We continue to train with the crew. Butch and Sonny have been fully engaged in all our simulation training. We're working off some backlog, closing the few remaining engineering products for flight. And in some cases, we're pulling some work in that we had planned for later, but since we've got the time, we're going to get it out of the way now. And of course, PCM1 is also being worked, and we're trying to hold those current plans with all of our engineering products and our hardware, software, et cetera, so that we can maintain the plan after CFT. Team's done a remarkable job at, number one, addressing all these issues and getting work done and coming up with good ideas of things that we can go do to make the best use of this time. Very proud of their efforts. So that's all I have this afternoon for you. And we'll be looking forward to the questions, and I'll turn it over to Joel.
Hey, thank you, Steve, and thank you, Mark, and thank you, everyone, for joining us today. Steve and Mark gave you a really good overview of the Boeing Starliner and where we're headed. I'll tell you from an ISS standpoint, the Starliner vehicle remains a high priority to the space station program. And as Mark said, when the Boeing team, the Commercial Crew Program, ULA are ready, it's my job to go find a slot on ISS, and that's the plan. And so having a second crew provider is very important to the agency and to our programs, and that's something that we are working hard to make sure that we achieve. From an ISS standpoint, it continues to be busy, as Mark said. Last Tuesday evening, we saw an awesome launch of NG-19 from Wallops Island. That vehicle delivered over 8,200 pounds of science research, crew supplies, and hardware, and it was captured and berthed to the ISS early Friday morning Central Time. And so the crew is already taking the supplies from that vehicle and using that to work on board the International Space Station. This Wednesday, we have a Russian spacewalk, and all the planning and scheduling is ready to go. We had a review today, and the teams are ready, and so we're looking forward to supporting the Russian spacewalk this Wednesday. Looking ahead, we have a Progress launch scheduled for the evening Central Time of August 22nd, August 22nd. And then, as you've heard last week, we're looking for the Crew 7 launch on the 25th, early in the morning, 2:49 Central Time. That sets us up for a docking a little less than 24 hours after launch. We also are planning the Soyuz in mid-September, Soyuz launch, where we'll have 2 Russians and an American on that vehicle. And then we're also working the late September Soyuz landing. And so from an ISS standpoint, the team continues to work the research and utilization as well as the visiting vehicles coming and going. And with that, I'll hand you back over to Leah.
Thank you all for those opening remarks. We'll now move into our question and answer portion of our call today. Again, please press *1 to raise your hand to ask a question and *2 to lower it if your question has been addressed. Please state your name, affiliation, limit yourself to 1 question and to whom your question is addressed. We'll start with Bill Harwood. Hi, Bill, are you there?
Hi,
Hello,
thanks for
can you
doing
hear me?
this.
We can hear you now.
Oh, thanks. Sorry about that. I guess this is for Mark and Steve both. Can you remind us of the long-range plans for Starliner with ISS, given the end of the program's coming up in 2030 or thereabouts? In other words, how many of these capsules are you going to end up actually flying? And really, I guess what I'm asking is there some kind of a drop-dead date for Starliner where if you don't get it going in time, you know, there's not any point in continuing or not much. Just given the time and money involved. I know it's a convoluted question, but I'm just curious if you have any thoughts you could share on that. Thanks.
Yeah, I'll start off, and then I'll let Mark add any of his
Fair
comments.
question.
I mean, our plan all along has been to have 2 different unique and
They're
diverse
not-
space transportation
You ain't gonna
systems.
get
We're
an
working
answer from
hard
this.
to get that in place. Once we do that, get Boeing through the crewed flight test and then the certification work for the vehicle, the plan would be to fly 1 Boeing flight and then 1 SpaceX flight for our crew rotations per year. And then if you just kind of look at taking us through the end of ISS, I mean, we've got plenty of flights for Boeing to go fly, and we're in good shape. And I know Mark and his team are working on each of those missions. He talked about the post-certification mission 1, known as Starliner 1, and they're working as well on Starliner 2 and 3 and 4 as well. So we'll see if Mark has anything to add.
Yeah, there's really no reason to change our plans. We've bought hardware for the 6 flights plus CFT. Still fits it well in the window that we have. There's additional flights are available outside of those 6 with other customers. So I think we are still committed, like we have been in the past, and we'll continue on.
Okay, thank you. Our next question is from Marcia Dunn.
Yes, hi. This question is for Mark. I'd like to hear more about the tape. You said some of the tape can stay, but how many hundreds of feet or whatever measurement, how much feet needs to be removed, and how much have you already
It's a capsule.
moved,
It doesn't have feet.
removed from the spacecraft? And I'm just wondering if you could explain the process. Does somebody just get in there and just sort of peel it away like I would do on a piece of paper? Could you explain that, please? Thanks.
Okay. Good question. We split the vehicle up into 12 zones. There's an upper zone, which is basically the top of the spacecraft, and the lower zone, or lower set of zones, we call the lower dome. And we're targeting each one of the zones with what's the criteria for the tape that has and how it's applied in those areas. So first step is if we think that it it needs to come off because it can propagate, then that's the first step, is try to take it off. And what we found is that most of our wiring is wrapped with, it has Teflon insulation. So just like your Teflon pans at home, stuff comes off them real easy. So when we started to attempt to take the tape off, it came off relatively easy. So on that upper dome area, we removed upwards of 80% of the tape. It came off very easily, and we just wrapped it with new tape. So we're in good shape there. I can't quantify it. I don't know how many feet of wiring we have, but you can imagine there's quite a bit of wiring in the capsule, and we did apply tape to protect the wire harnesses and quite a few areas from chafing and collateral damage, that kind of thing. We get down to the lower dome, and we'll do the same type of approach. And if there comes an area where the tape is going to be difficult to remove and we could possibly cause damage, then we'll look at another remediation technique. The team has been testing. They've found that there are protective barriers that we can put in between the wire harnesses. They found protective coatings. We could wrap with acceptable tape in absence of taking the tape off. And of course, there's areas we can just leave alone, because through testing we found that the flammability does not propagate in some cases. So we'll apply, based on the area, we'll apply the right remediation technique.
Our next question is from Jeff Faust.
Hey, good afternoon. A question to follow up on Bill Harwood's question. In terms of the near-term manifest, this is a question probably for Steve Stitch. If Starliner flies as soon as next March on the crew flight test, do you think it would be possible to do the first post-certification mission in the second half of next year, or would you wait until 2025 to fly that mission?
Yeah, that's a good question. I think we need to look at exactly where we fly the crewed flight test first, and Joel and I and Mark and the Boeing team will have to work on where we put that crewed flight test, and then kind of look forward and see, where does that Starliner 1 flight fit? Could we fit it into the end of next year? We've been flying these rotations in 2 different slots, kind of a February slot and an August slot, and we'll have to look and see. It's probably a little too early to tell whether we could fit that flight in or not. We would like to fly it as soon as we can. And we also have to work, since Mark and the Boeing team have moved out on what we call the Dash 511 parachutes. I suspect that when that flight flies, from a hardware availability perspective, might be driven by parachutes. We'll have to go work through that whole schedule and see how it looks, but it's a little too early to tell.
Our next question is from Eric Berger.
Hi, thanks very much for doing this. I guess a question for Steve. Looking back at the parachute issue, when SpaceX switched from Mark II to Mark III, obviously that was a pretty big change, but they had to repeat their entire series of parachute tests back in 2019. And I think there was about 2 dozen tests. And is Boeing doing just the 1 drop test this November, as Mark mentioned, or is there more? And can you discuss why there's just a single test of the soft link issue? Thank you.
Just said that they've tested it multiple.
Yeah.
Never mind.
Thanks for the question, Eric. When we redesigned the parachute system for SpaceX, it was a significant redesign of that system because we learned that we have a phenomenon we call asymmetry, where one part of the parachute pressurizes more than the others and caused higher loadings on part of the canopy and the suspension lines. So when we did that, moving from the Mark II to the Mark III, we required more drop tests, and there was a number of development tests and a number of tests for certification for flight. What we're talking about here is really upgrading what I would call is a loop that transfers the load. This thing called a soft link. It's a Kevlar loop. It's a Kevlar piece of cord that is in 8 locations on each of the canopies. And then the other change on the Dash 511 chutes is a stronger joint where at the top of the canopy, around the canopy, where there's a suspension line, there's 80 of those that come down where that joint attaches. And so when we looked at the changes that we're talking about, we felt like we only needed one test to verify both the soft link and the new Dash 511 joint, given all the other tests and given how close both the soft link redesign and the joint redesign were to what we have already tested in all the previous parachute drop tests. So the design changes were, I would say, minimal, as opposed to what we had for Dragon, which was really a whole-scale change in the canopy.
Our next question is from Irene Klotz.
Thanks very much. My question's for Mark. I realize that throughout this whole program, Boeing has been very consistent on saying that the purpose of this is for NASA. But in light of what the company has been sinking in of its own costs at this point, could you talk a little bit about what the company's long-term plans for Starliner are?
So
they have other customers.
Our contract goes through PCM 6, and of course that carries us out to the end of the decade. And so, again, like I said earlier, very committed to fulfilling our obligations and continuing to develop the vehicle and flying those missions. And very excited about it. This is a pretty exciting business. Beyond that, that's new business. That's what we talk about as time goes on, as we learn more about the market, and it's all part of all companies' long-range business plans. We go through those each year and determine, how we're going to proceed. So, but as far as what we have on our existing horizon, again, we're one of 2 providers, and it's a great opportunity for us, and it's like Steve and Joel have said, they really need us to be there. So we're committed to providing that service.
Next up, we have Joey Roulette.
Thanks. Quick question for Steve. You had said that, I think, Steve, you said 98% complete with certification towards CFT. Is that, does that include, is that just the parachutes up the next 2% that you guys are looking at, or is there anything else that you're kind of looking to certify beyond that? And then for Joel, unrelated to Starliner, I was wondering if the investigation into the Soyuz coolant leak is closed after it seems NASA determined that the cause was linked to an external force, and if it is closed, or regardless, what is that external force? Do you have any idea what that is? Thanks.
I'll start with what's remaining to be closed out for the crewed flight test certification. It really is in, I would say, the following areas. One, obviously parachutes. We'll have some updates to some of the certification products that has been delivered, and we'll work through that and work through closing those out. We have the final certification analysis and products for the abort system. So we have mandated a pretty stringent abort requirement that all the way from the launch pad all the way to reaching orbit. 95% of the cases have to pass in actually looking at 10-second slices in time, and so that's one area that we're very close to getting that approved. And then we have, a couple of areas in the structure that we still have to go work on and approve, but it's really down to those areas, plus there'll be, for the the remaining P213 tape, there'll be something called a materials usage agreement, which is sort of an agreement that says between NASA and Boeing, we agree the flight rationale for each area of any tape that would remain. We'll look at the wiring, we'll look at the critical functions in that wiring, we'll look at the voltages and the powers required, and then what mitigations have been employed. And those are kind of the main areas that are remaining to get certified for flight. And then I'll hand it over to Joel for the second question.
Hey, thanks, Steve. As far as the Soyuz investigation, it is not closed. We still have a number of review boards to go through. In fact, tomorrow we are talking at the Space Station Control Board about the status of the investigation team. We'll also go through the agency flight readiness review process. We'll be briefing at a program level and then at an agency level. And then so until the final flight readiness review, that work will continue. And then at the final flight readiness review is when we'll have the final go. As far as the external force, at this time, again, both the U.S. specialists and the Russian specialists have concluded that it's some type of external force. Is it orbital debris? That would be the most logical, but it's really hard to identify exactly what happened on that. But the teams have gone through, and again, they've looked at manufacturing, they've looked at technicians, making sure there's not a new technician. They've looked at how the leak occurred and the mechanics of the leak, talking to the material specialist. We didn't see, when we saw the leak, it went from everything was good till you lost all the coolant. And so none of that is indicative of manufacturing or tooling or anything like that. And so right now, orbital debris would be the leading candidate of the cause.
All right, our next question comes from Arya Alamahodai.
Hi, thanks very much. My question is for Steve and Mark. Steve, you briefly talked about some of the independent review teams that will be looking at Starliner. Can you talk in a little bit more detail about those independent teams and the timeline for their reviews? Thanks very much.
I'll talk about what we're doing on the NASA side, and then I'll let Mark talk about the Boeing side. So what we've agreed to do on the NASA side is, again, the chief engineer already has done one round of interviews with each of the subsystem managers, again, across the vehicle, the prop system, the life support system, the thermal protection, parachutes, wiring, so forth. Ask me on the question, hey, given the late finds, is there anything else that you would be concerned about in your system that we should go deep dive? And so far, we really haven't turned up anything big, because I do think our certification process is very thorough, and it looks at things from different angles relative to certain certification products that are required, and then a hazard analysis which looks across the systems and shows that you have a control for any hazard. The second thing we're doing within NASA is we're going to have Joe Pellicciati, who's the chief engineer for the agency, his deputy John McManaman, and also Tim Wilson do a deep dive on the P213 tape, on the parachutes, and then any other things that we have uncovered through our reviews. They do this on a weekly basis with our chief engineers, who bring technical issues to them. And what I like about this process is that they have different backgrounds than we have. Joe Pellicciati has a bit of a robotic spacecraft background, and then Tim Wilson, the head of the NASA Engineering and Safety Center, has a lot of experience relative to rocket engines and rocket tests, and so they ask questions and come at things from a different angle. We also said on the NASA side we would do one last look at two major areas. One, the propulsion system on the crew module, just to make sure we haven't missed anything there, based on lessons that we've continued to learn as we fly Dragon, and then the service module prop system as well. So I feel like we've got a pretty thorough look at different areas with the right expertise. I also do feel like within NASA we have independent technical reporting. In other words, engineering reports up through a different organization than the commercial crew program, as does safety and mission assurance and the flight ops directorate where the crew resides. So I feel like we've got a good look across the systems, and then we'll see if we miss something else. We have a little bit of time to step back and do a bit of a deep dive, and I'll turn it over to Mark, and he can share what Boeing is planning.
All right, thanks, Steve. We took a similar but a little bit different approach inside the Boeing company with reviewing a lot of the decisions that we've made leading up to CFT. So we have the engineering products, which are made up of the variances and our software configuration, and for the verification products on the engineering side. And so what we did was we're looking at all of those products and looking for where we made decisions to make sure that we're confident in the decisions that we made. That was done with a panel of experts outside the program, above the program, to look at each one of the products and determine whether or not, in their view, the decisions were made correctly. We're also looking at our hazard reports in the same manner. And then we've also looked at work that we decided to not do for CFT, but do for later flights. And are those smart decisions, or those things that we should pull into CFT? And we're through a great deal of that review, and really it hasn't uncovered any unacceptable conditions. A lot of good discussions about why the decisions were made, and good support on those. The next step is a few targeted areas where we're going to bring in another level of engineering support to dig a little bit deeper in some of these targeted areas, to look down into some of the details of the testing that was done, the analysis that was performed, et cetera, to make sure that we're covered in those targeted areas. And we expect that to be done by the end of September into October timeframe. But again, so far, nothing substantial has been found, and I think it's another confidence builder that, you know, the problems that we did find were found as part of the process, and we have a good solid process. It just, in this case, we found things later than we wanted to.
Our next question is from Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks for taking my question. Suppose it's for Steve Stitch. With the adjustment of the Crew 8 crew with the addition of Jeanette Epps coming over from Starliner 1, can you talk about what the crew for Starliner 1 looks like at this point, and if there are any additional changes to the makeup that are foreseen in the future? Thanks.
Yeah, we have named two of the crew members for Starliner 1. We have named the commander, which is Scott Tingle, and the pilot, which is Mike Fink. And, you know, we'll name an additional 2 mission specialists at a later time. And, you know, what we've been doing with our crew members is, in some cases, doing, I would say, joint training on both Starliner and Dragon. And in this case, you know, Jeanette Epps is now, we're excited to watch her fly on Crew 8, and she has been doing joint training for both for a while, and we just announced publicly the crew of Crew 8 last week. So.
Thank you. Next question is from Issam Ahmed.
Hi, this is a question perhaps for Steve. You mentioned that the specifications about the P213 tape were a little ambiguous and not very clear. I was wondering if that points to a wider issue in the industry, given that it seems to be, from what I can tell, used more widely in the industry. Could this potentially cause any other issues? And did SpaceX make use of such tape, or did they have a different solution altogether? Could you share that with us? Thank you.
Yeah, I'll take the first part first. Relative to the confusion, the database sort of lists different applications of the tape. For example, if you use it on a metallic, like a metallic aluminum structure, well, the database would tell you that you could use it up to a 30% concentration of oxygen, which is well above what would be in a typical spacecraft cabin environment. So it just wasn't very clear what the constraints were for the wiring, and so we'll go back and clean that up. We've actually shared that data across all the programs. I know Joel sent a letter over to all the international partner countries as well as the cargo vehicle providers for the space station program. So we've been sharing that data, and I think this is one of the things that I've been talking to our engineering community about. Perhaps there's a bit of a gap in how we share information for materials usage across our programs. It's something we need to look at as we have more and more programs working on hardware development for exploration. Second question relative to SpaceX, they did have some tape that they were using before the first crewed flight, and we were able to remediate that. It was only in a couple areas under the floor, and we were able to take that tape off. And so they're not using the tape in the same application that Boeing is using.
Next question is from Max Hoppenstedt with The Washington Post.
Hi, thank you. I had a question for Mark, I guess. You mentioned that the decision to move ahead with test flight would be all the way up to your CEO. So I was wondering what David Calhoun has said to these latest delays, and I guess what is the sentiment in Boeing given these changes will also mean more costs before testing and flying. And then just to confirm, am I understanding correctly that the decision for the test flight in March has not been yet made finally, or has that decision to fly in March been made? Thank you.
Let's start with the last piece first. What I'm commenting to is our readiness with the spacecraft. And so we'll be ready at the beginning of March, and there's just work ahead of us to determine when that launch date is based on our readiness. So we'll figure that out as time goes on with NASA. As far as the test flight and the timing, et cetera, I think was your question. We're going to do the right thing with respect to the safety of the vehicle, and that is first and foremost in every discussion that we have. And when it comes out that the answer is to do B because that's the safest thing for the vehicle, that's what we do, and then we figure out what the outcome of that is, what are the ramifications of making that decision. And that has been the approach all along. Actually, frankly, has been my experience in human spaceflight since the day I started in 1985. It's the way we do business, and so it's not foreign to our management team inside of Boeing, and again, it's the way we do business in human spaceflight. So I think that's the approach that we took, and I would never second guess that.
And just to clarify and add on to what Mark said about vehicle readiness, and what I know everybody would like is what's the launch date, and what Mark said is the vehicle will be ready in the March timeframe, and then what we have to do, working with Joel, is we have to look at what else is in that timeframe relative to ISS. For example, March is typically the month where the Russians will swap out their Soyuz spacecraft and crews. They'll do a crew rotation just like we do with our crews as well, and so we've got to look at that, and then other cargo flights around that time frame, and then Mark and his team have to go work with ULA, and that's when we are able to pin down a specific launch date, when we go work through all those things. We have not done that step yet. We have not taken the vehicle readiness and then mapped it into when we could go find a date that works with ISS and works with ULA, and that's really the next steps. So, and we talked about, we had our previous telecon on June 1st, and so we'll come back in a couple of months and update you again on where we're at, and hopefully by that point in time we'll have narrowed down when the launch date is, and we can talk about that. And then I would echo everything that Mark said about about safety and redesigning hardware for crew flight. I think you've seen that with both SpaceX and Boeing, that when something is not safe and not acceptable for flight, that they'll go off and make either a design change the hardware, change the software. If I look back at Boeing, we've had several valves that have been redesigned, many areas of the spacecraft that have required additional modifications just to get to a safe crewed flight. And to me, that shows Boeing's commitment to Starliner for both the commercial crew program and ISS, but beyond that, I've seen nothing but an unwavering commitment from Boeing to do the right things. And as Mark said, many of these decisions go all the way up to the CEO of Boeing, and he's very supportive of the program.
The next question comes from Ken Kramer with Space Up Close.
Hello, thank you for doing this and for taking my question. It's for NASA and Boeing. I'd like to follow up on the parachute tests. I'm just a little surprised you're only going to do one test. So I'd like to know, have you got an independent opinion on this test, whether the one is sufficient? And I'd like to know, do you have a backup plan in case more than one is needed? And how long will it take you to evaluate the results of this lone test to give you confidence you could move forward if it works out? Thank you.
Yeah, I'll start off, and then we'll let Mark add his comments as well. So the team came to the conclusion that we only needed one test based on how much of the parachute system has changed, how much the mass has changed, how much the overall volume has changed. What we look for in parachute drop test is things that really appreciably change the way it would deploy, the way it comes out of it. Each parachute is packed in a bag. That bag is kind of pulled out of the parachute compartment, and then the parachute itself comes out of that bag and begins to inflate in various stages. And then these particular parachutes have what's called two reefing stages. In other words, the parachute can't go from out of the bag to full open because it would be overloaded. And so what the team looks for is things that would change that whole deployment sequence, that dynamics, the way that they're reefed. And when they look at these two changes, they're structural changes to a couple components that aren't, I would say, integral for exactly how that parachute inflates. We have had the NESC, NASA Engineering Safety Center, as part of the assessments of parachutes. We also are very fortunate to have a few individuals that have actual parachute heritage all the way back to Apollo, and they've advised us that these changes are, in that realm where maybe only one drop test should be required. And if we learn something on that test, we'll get another parachute and design another drop test, and we'll go do a second test. So, and I'll see if Mark has anything to add.
You characterized it very well, and I think it's also important to point out that, we have some of the best experts on parachutes between NASA, Boeing, and Airborne, and you highlighted a couple of others that came in as independent overseers of the decision as well. So I don't think it should be taken lightly that our experts unanimously agree that this is the appropriate approach to guarantee that we have good chutes. We'll also do the same inside of Boeing as the test matures to make sure that our engineering community all the way up through our different general managers, staffs understand the test and support it as well.
Thank you both. The next question comes from David Curley with the Discovery Channel.
Thanks very much. Still on parachutes, and my apologies. My phone dropped off just when you Stitch were talking about it, and didn't get back until Mark had kind of gone through some of it. But you mentioned that looking at the parachutes, you studied the entire system. You didn't say whether or not additional problems were found in other parts of the canopy during that study. And moving to the next generation and requiring the test, was that because problems were found, or just the timing issue that the next generation is going to be available now with the delays? Thank you.
Yeah, I could talk about the review that was done, and perhaps Mark can address this next generation, what we call the Dash 511s. I would say when we did the review and we looked at all the, what it's called is seam and joint testing. In other words, there's a sewn joint on the canopy or on the structural grid of the parachute, and then what has to take place is that you do a certain number of pull tests, and you assess the capability of that joint given the forces that it will see in flight as the deployment happens, and then as it hangs finally, as the capsule hangs under the parachutes. And when we did that review, we found a couple areas where perhaps there was needed to be a couple more tests done to complete. Typically, I think sometimes there's 5 tests required, sometimes 10, and so there was a couple areas where we wanted to go do a few more tests. But when we looked at the margins in those areas, we didn't have any concern. So it was good that we did the thorough review. We also did a review of all the drawings of the parachutes, and then how those drawings are turning into what I would almost call a work instruction, so that there's a technician then that can go, sew that particular part of the canopy together or put that joint together, and we didn't see anything unusual with any of that. We also brought in an expert on what's called the seam and joint testing from the NESC, and he went through all the data, and all the margins are acceptable for flight, and I'll let Mark talk about the decision on the Dash 511s.
Thanks, Steve. So the Dash 511s, we were faced with 2 really good decisions. Both decisions would have been perfectly fine to make, whether we were to take the 509s, which came off of CFT, and apply the soft link to those and fly those, or go straight to the 511s. And so, you can't really make a mistake when you have 2 good decisions in front of you. But the decision to go to the 511s was really that, they both had a little bit of pros and cons. The 511s took a little longer, and the 509s they had to be repacked again, which takes a little bit of strength away from them. So we said, let's just we're going to go to the 511s anyways. Let's go to the 511s and do the testing that's required. Piggybacking on the last question, as Steve has said, the configuration changes to these different configuration chutes is very, very minor. And going from the 509s to the 511s, besides the soft link being added, there's just a row of stitching that is being added to where the riser comes up into the canopy. So it's a relatively small change, and this test is very sufficient to test that change and make sure that it is sufficient for flight. So we made the decision to go to the 511s and do the drop test, and again, it was a little bit of a penalty on the time that it took to get the chutes, but it's worth it.
Thank you. Our next question is from Micah Maidenberg with the Wall Street Journal.
Thank you. Mark, just how confident are you that Boeing can achieve just readiness in March, given that various previous dates for Starliner, haven't been met? And are you, fairly confident at this point there won't be any further new issues that emerge? Thanks.
So I can talk to the past, and we always learn from the past. And, we had set some previous dates, but we had work in front of us that was a lot of first-time projects or first-time products that had to be approved. And we made our best guess at the forecast that what it would take to get those products approved, and it took longer than we had planned. Again, we do it right, so it takes the time that it's going to take in order to get through the process. This time, the work that we have in front of us is rather straightforward. We have the parachutes that we have being built at the supplier, and we're working with the supplier to ensure the delivery. We have the tape work that's being done that will be done well in advance of the need. And then we also have the parachute drop test that, again, has quite a bit of margin for it to be performed, the analysis to be done, and then us to be ready for flight. So, the critical path goes through the readiness of the parachutes. We're working closely with the supplier to assure our readiness. We put some margin in that. And, there's always the mystery of, something else that can pop up as we finish the build of the vehicle and get it ready to be stacked at the launch pad. And we can all just, imagine what might happen. But, it's not what we work to. We work to plans. We work to forecasts. We work to what we know we have to do. And we have a pretty good schedule laid out to get there.
And the last question we'll have today is from Joey Roulette with Reuters.
Thanks. Quick one for Steve. Is Starliner's battery system considered a safety critical item? And if so, does it satisfy that safety factor of 2.0 for CFT that you mentioned earlier on the call? And Joel, is the investigation into that Nauka anomaly in 2021 complete between NASA and Roscosmos? Thanks.
Yeah, I'll take the battery question first, and then there's a little difference, I would say, in the batteries versus the soft link. The soft link really is a factor of safety at 2.0, means that essentially you could pull on that joint with twice the force that you'll ever see in flight, and it would handle that kind of load. So it's got that kind of margin baked into it. The batteries, there really isn't a safety factor per se for the batteries. I would say we continue to look at the battery system overall. We've got a redesign plan, and we've been working on that hand in hand with Boeing. We have done some additional testing on the cells, and we are now understanding how the cells perform at lower states of charge, which gives us a little more confidence on the battery system even for crewed flight test. And then we'll do another test likely here in September to test the whole integrated battery system, and we'll have that done before crewed flight test. Right now, everybody has approved the batteries for the crewed flight test, and we have some mitigations in place for the Starliner 1 flight, which will go work through the board process. And then, as I've said, long term, we've got a battery redesign planned, and that's really to make them what's called passively propagation resistant should that cell overheat, which we've never seen with these particular cells. I think I talked before that we do a lot of extra screening on the cells for these batteries as compared to the cells that you might have in your laptop or other vehicle. They go through an extensive screening process. We look for FOD in cells. We take some of the cells apart. We keep them in a freezer. There's all kinds of things we do to protect the cells and batteries for flight. And I'll let Joel answer the very last question.
Okay. On the NIUCA, or often called the Multipurpose Laboratory Module, or MLM, that work is closed. It's transitioned to more of a documenting the lessons learned with the anomaly and how we can pass that along to other programs at NASA and other programs that we do with our international partners and domestic partners.
All right, everyone, that's the time we have for today and all of our questions. Thank you very much for joining us for this update on the Boeing Starliner spacecraft and our future plans through the Commercial Crew Program. You can learn the latest information at blogs.nasa.gov/commercialcrew, and we'll talk to you again soon.
All right, so we had Super Heavy getting lifted over there, and yeah, that's pretty good news. That's good news. I think an important thing to cover right off the bat is that one of the last questions, that was asked was, the Boeing gentleman talked about, this is our first time doing a lot of this stuff, which after the last Starliner progress update from a couple months ago, I kind of had a theory that Starliner, it's not that the engineers that are working on Starliner are bad. I wouldn't say Starliner is a bad piece of engineering. I think it's a very good piece of engineering. And I think that the management for the Starliner program is actually pretty freaking good. It reeks of inexperience, though. Not necessarily. I mean, you do have guys that worked shuttle working on Starliner, absolutely. It's just when you have a new capsule, a company that's never built, never engineered a capsule in the past, you're going to get some inexperience. You're going to get some surprises. It doesn't matter if it's Boeing. It doesn't matter if it's Lockheed. It doesn't even matter if it's SpaceX. You're going to get some surprises here and there. In this particular case, the stringent testing of Starliner is catching a lot of problems. That tells me that Starliner's testing regime is actually really stringent, and the management for the program is actually really good because they're catching all these problems here. You're catching all the problems down here and not up there. With the 0511 links on the parachutes, the tape, which the tape is really interesting because NASA's documentation on this tape was pretty fragmented, but it said it was okay, and then the manufacturer of the tape said it was okay, and then Boeing went and did extensive testing to be absolutely sure and found that it wasn't okay. So what do you do? If NASA says it's okay relatively and and the manufacturer of the tape says it's okay, what do? You go and test it to be sure, and they found, who knew? That shows that they didn't take it at face value and figured out that the tape could be flammable in certain scenarios, which, you don't want fire in your capsule. That's not good. So this shows me that Boeing is under a very stringent testing regime here. And the problems that they found here, like kind of at this point, are just the result of stringent testing. Like, I say it's inexperience because, they've never operated a capsule before. So, or they never built a capsule. They've operated spacecraft in the past, or at least companies that Boeing owned or merged with has done that in the past, but that's a whole different project. Also, operating a spacecraft is not building one. Those are way different things. Just because you have a license doesn't mean you can assemble an automobile. Build your own, right? That doesn't work that way. Those are two very different things. Building a capsule is not operating one. So, I mean, honestly, given the time frame for when this contract was awarded, I think they're doing okay. I think this is, people are going to say, oh my gosh, they're not going to be ready until March. But honestly, finding these problems right now is good. Finding these problems now and being ready when you're ready is a good thing. Those engineers sounded exhausted. They've definitely been working. So, yeah. What's happening with Starship? They took Booster 9 off of the OLM. Great job on the NSF commentary yesterday. How you feeling after that? Tired, man. Tired. Hosting an NSF stream is not hosting this stream. Those are two different things. I have to watch. I'm keeping up with Twitch chat. I'm keeping up with YouTube chat. I'm keeping up with the producers in the back channel, and also providing commentary on everything. It's a lot more to keep track of. A little bit more difficult, and that kind of screws with you. And like sometimes the explanations aren't as like straightforward of what I'm saying, like as they are here. But it's I feel I did okay. It's a lot of work, dude. But anyway, with Starliner, I think that's really good news. They solved the parachute link problem. They just got to basically put it through a qualification test later this year, and they'll be ready to go by March. That's good and good testing and engineering on Boeing for figuring out that failure mode with the tape. I think Starliner still, after all, is going to be a good capsule. But this just kind of shows, I think above everything else, this illustrates cost plus. Why cost plus is a good idea, a cost plus contract. Because, guys, I'll be honest with you. You're going to get bumps in the road with any spacecraft you design. This happened with the Apollo CSM, Space Shuttle, Mercury Gemini capsules, Dragon. It's happened with Dragon. It's going to happen with Starliner. It's going to happen with, Sierra Space, with Dream Chaser. It's going to happen. You're going to get bumps in the road. Can you imagine? Think about this for a second. Not every company is going to have an extra $1 billion to throw at a capsule to fix it. What if NASA had chosen another contractor and they wouldn't have been able to get enough money to pay out of pocket for these bumps in the road that you get when you're developing really advanced and really complicated spacecraft? Then NASA would be up poop creek without a paddle. You know, I think this is a good reason. This is a reason why cost-plus contracts exist, because you can't predict the future. You know, I mean, I think it's up to NASA simultaneously to do their due diligence to make sure that they're going with the best bet, and that way you don't, you know, if you do a cost-plus contract with, you know, a provider that you're confident that they can deliver, and the budget won't balloon like crazy. But well, you go, once again, you can't predict the future. When the Starliner contract was awarded, Boeing was the safe bet. SpaceX was the gamble. That was 10 years ago. Well, 9, but you get the idea. So, I would contend to say that funding Starliner on firm fixed pricing is kind of the reason why it's taking so long. Just food for thought. But either way, you know, if Boeing has put in $1 billion out of their own pocket, and they're going to see it through. So, just, I don't know, food for thought. Interesting. How long was Dragon under development? The first contracts for Dragon style rolled around in 2008 for an uncrewed version for commercial resupply. And then the Commercial Crew Program, which was a follow-up to Commercial Orbital Transport Services, came around in 2014. So, I think it's important to look at another. You know, you reminded me. It's important to look at the entire timeline. SpaceX, with no experience building capsules at all, got a Dragon contract in 2008, Commercial Crew contract in 2014, and then if you look at Dragon kind of getting to its, you know, more finalized version with Dragon 2 and Dragon 2 Cargo, right? Those variants basically didn't come around until 2020. So from 2008 to 2020 for the whole thing, and that's having prior flight experience. Took 12 years. Now, if you look at Boeing and you look at Starliner, once again, no prior experience. Boeing has no experience. Well, now they do, but Boeing had no experience prior of building and designing a capsule. Look at the time frame. It's been 9 years. That's kind of on par with SpaceX. It's kind of on par. It's about the same. I mean, Boeing's capsule might be a little bit, I think it's a little bit more expensive overall, but see what I'm talking about? SpaceX went, you know, they had a lot of flight experience with an uncrewed cargo resupply vehicle when Commercial Crew was awarded, and it still took them 6 years to get crew flight under control. Boeing with no experience has taken basically the amount of time it took from the Dragon capsule's first contract to flying crew. This stuff takes time, dudes. Stuff takes time. Like, it takes time. But Boeing will get it right, and this is good news. They're going to be ready to go by March, which is good. Hey, Ark. 36-month resub. What's that? The Apollo program is a really good example. When reviewing the Apollo 1 accident, they discovered all sorts of tools and fasteners left behind in the walls and equipment spaces of the capsule. It changed the entire way we thought about it, or didn't. Yep. However, we already know that NASA admitted to thinking they should have given Boeing equal attention. Yeah. Gossar, 33-month resub. There's no doubt, Hellfish, that NASA kind of thought Boeing would be okay. But the reality of the situation is that by the time Commercial Crew rolled around in 2014, all of any U.S. experience in human spaceflight was scattered to the wind because after the shuttle program disbanded, those people didn't just wait for another human spaceflight vehicle to move around. All the technical expertise they had from the shuttle program, they got rid of. They scattered them to the winds. So now you're trying to build a spacecraft with retaining some technical expertise, maybe at the upper management levels. And guess what? Just because it's like what people always say about the Saturn V. Just because we have the blueprints to the Saturn V doesn't mean we could just reproduce it like that. It's going to take time. And that's with designs that we have already. Starliner's a clean sheet design. This is why I get so annoyed. And you know what's funny? They talked about it on NASA Spaceflight yesterday. They talked about it, the time after the shuttle stopped flying. Chris B talked about it, how much it sucked. I think that is the biggest thing. You don't just retain that technical expertise and institutional knowledge just because just because you move to another program. You know what I mean? That expertise goes away. It gets scattered to the wind. And unless you have a program that goes over a long, long series of time, like the shuttle program, for instance, guess what? If that program ends, that's it. Like, how much of the Apollo engineers ended up making it into the shuttle program? Not a lot. I mean, that's because of budget cuts and whatnot, but not a lot.
Discovery.
See what I'm talking about? You don't... I think that's important to understand. You don't just retain that institutional knowledge. You end a program, yeah, great. You have the books. You have the books about it, but just because you have the blueprints doesn't mean you have the expertise. Which is why I kind of not really too upset that Boeing's capsule is taking all this time. I mean, I might have the benefit of hindsight here, but yeah, it takes about 10 years to build a human-rated spacecraft. It takes about a decade. Look at the Apollo program. And the Apollo program's with the taps open. The capsule's design started coming around 1961. They didn't fly with people on it until 68. That's with the Apollo program's budget going after it, which is crazy. Shuttle came around 1972, first flew in 1981, 9 years. See what I'm talking about? Look at Dragon, 12 years for Dragon. I mean, SpaceX, you could say 6, but there's no way that SpaceX didn't have crew-rated, at least an idea for crew-rated designs before commercial crew came around. There's no way. So SpaceX did it in 6, which is pretty damn impressive, regardless, right? But they had prior experience. That's an important thing to understand. And if you look at Starliner, 9 years, 10 years, I mean, that's following the curve pretty well, actually. Hey, Brand, 68-month resub. Take time like reaching 68 months. Yeah, sure. Yes, that does take time. Hindsight now says be sure to keep an eye on those building manned spacecraft. Not invasively, but they still should have been there. Well, even the controls, you could make the argument for controls and independent review teams with capsules. Hellfish, we stopped doing that when we stopped making capsules. Funny how that works. Or spacecraft, I guess. We've done thousands of years worth of experience when we trashed Saturn V in the shuttle. Bingo. And then NASA made the same mistakes again, as they did during Apollo 1. Interesting, right? Related to losing experience, the test reactor at Lawrence Livermore was being cleaned out and such, and they had tons of recorded data that was just going to be thrown away. A major lab like that wasn't going to save years of important test reactor data. Yep. It's like giving your average mechanic blueprints to the McLaren P1 and expecting them to have it built in 2 months. Stuff takes time. So for the moon mission, NASA needs to certify both Starship lander and the booster, right? So what is the current time frame? Just the lander, Marco. Booster doesn't need to be... I don't understand what certified means. What do you mean by certified in this regard? Now we're gaining it back, Oz. Yeah, exactly. Which is why, I mean, dude, like I said, canceling Constellation was a mistake. That was a really, really bad move. It did bolster the commercial market, and that's very good. That's a good thing. But it did set us back about 10 years. It was... And the funny thing is that Neil Armstrong and Gene Cernan testified to Congress in 2011 basically saying that. It's stupid to get rid of all of our momentum with this. We should keep our foot on the gas pedal or else we're going to lose about a decade. And that's... You know what the funny thing is? They said that in 2011, at the beginning of the 20-teens. And guess what? SpaceX flew in 2020. 9 years later. Weird how that works, right? It's almost like Neil Armstrong and Gene Cernan know something about making spacecraft. Or they knew something. They're no longer with us, which really sucks. Yeah, they testified to Congress, and Congress said, no. Yep. Oh yeah, that will be looked at in history for a long time. Now, don't get me wrong, the pivot to commercial is great. the pivot to commercial is great in bolstering the commercial, like, low Earth orbit market, but that's nothing the Constellation program wasn't going to do anyway, which really sucks. That pivot to commercial was pitched that way by people that basically wanted to gut the space program and then pawn it off to commercial because it's cheaper, which they were already doing. They basically got rid of the big expensive parts and kept the parts that were cost effective and then pitched it as a new way of thinking, which is funny to me. But hey, it is what it is, dude. The funny thing is that Congress got wind of that, and, you know, we always blame Congress for SLS. We always, you know, oh, the SLS was designed by committee, SLS was designed by Congress. Blah, blah. Yeah, it was designed by Congress because they were going to pull the plug on NASA's human spaceflight program. That's why. They were going to pull the plug. They wanted to go all commercial. And NASA said, or not NASA, Congress said, the hell you're going to do that? Funny story. They don't tell you that part. They even refer to it as Dragon 2. They absolutely see it as a revision of the first one that they rolled out with experience into the new one. Correct. Yeah, man. So, long story short, at the end of the day, guys, engineering spacecrafts takes time. You want to build a new spacecraft from scratch that's human rated per NASA standards? Kiss the next 10 years goodbye and a lot of money. But you do get some good capability. Nice, eh? That's great footage. Dash cam. Well, not dash cam, but... yeah, I mean, Congress freaked out. Congress saved NASA's human spaceflight program in this regard. Yeah. Interesting, right? Anyway, good news for Starliner either way. I'm pretty happy that they're getting their stuff together. It's just, yeah, this happens when it's inexperience, man. And it's funny because they said that. The guy in the press interview said that this was our first time doing a lot of things that we didn't necessarily know how to do. Yeah, because, you know, when the shuttle program ended and Constellation got canceled, they had to fire all the people that knew anything, that had any wherewithal how to do all this. Funny how that works. My real question is, what is the expected lifetime of their low Earth orbit capsules? Could we use them for 50 years as a taxi? I think that depends on market conditions. It depends on market conditions. Using them for 50 years as a taxi, who knows? Like, if the market takes off, you know, maybe the industry moves to full reuse. Who knows? I don't know nothing about that, Aaron. I mean, maybe. I don't know. I'll wait for official confirmation before we go and talk about that. Guess it's been totally civil. Actually, Belk, not too bad. I mean, Berger had a little bit of a presumptuous question, but yeah, not too bad. Starliner's on the right track. They fixed the parachute links, and the tape problem has been solved. I would say that the tape problem was not Boeing's fault. If the manufacturer says it's good, and NASA has documentation that says it's good, good on you for going and testing it to be absolutely sure. I think that is a gold star for Boeing, to be 100% honest with you. They're going to be ready by March, pending some qualification tests for the chutes. And yeah, they should be good to go. Actually, pretty damn good news. Good stuff. Totally unrelated question. How's Russia's space program doing at the moment? It kind of just kept doing its thing, Hater. They're doing okay. I mean, Soyuz is a pretty grandfathered in design, like, and just like we want, you know, American rockets from American soil with American contractors, like the Soyuz is not necessarily dependent on foreign contractors for the parts, for the supply chains for it. So yeah, they kind of just kept doing the same thing. They did have an idiot running their space program for a little while, but he made a fool of himself, and then he made a lateral shift to the you know, the special military operation that they're working on, and literally got his dick blown off. No, that's not an exaggeration. Yeah. Oh, yeah. They put him on their whole little fun time over there, and he got hit with shrapnel, and it literally chopped his schlong off. True story. He got shafted. Yeah. No, that guy. Yeah, I don't like what he ended up doing. I think he was doing good things for the space program until the whole Ukraine thing went down, and frick him for thinking that. The guy that replaced him is a guy by the name of Yuri Borzimov. Borzimov's all right. He's like, look, I don't want nothing to do with the politics involved here. We just want to do space stuff. We just want to do space stuff. I'm not gonna make this a big deal. Like, let's just keep doing space stuff. Like he went in a presser and literally said that. He said, despite what you might think, I'm not doing what the last guy did. I don't need my dick getting blown off in the Ukraine. Yeah, I just want to keep going, and that's it. No bull crap. So Yuri Borzimov's actually been doing he's been doing a good job. Seriously, their program, the space program is just kind of doing their thing. More de-shafted. It's so cute that you believe that, but pretend that it's that. Pretend what, Ando? I don't. The guy says he wants to keep politics out of the Russian space program. He said that in a press conference. Like, what am I pretending here? Like, why is? I don't know. I mean, I don't know what to make of that. He's been quiet. He's just doing his thing. Yeah, exactly. Because the other guy, if Rogozin had kept going, he would have wiped his butt with the ISS contracts with NASA, and then NASA would have said, "Fine, piss off then," and then the Russian space program would have gone bankrupt. That's why he got moved. Yeah, FunkyBot, that's right. He's not an independent entity like we like it in the West here. I don't understand. I know this. But the context of this question was, how's the Russian space program doing? So I've answered the question. Like, you guys... Like, the context has been heavily inferred here that I don't really agree with what's going on. Like, I don't understand why people presume. You're literally Eric Bergering me right now. It's not... I don't like that. I don't like that. Please don't do that. Honestly, I figured the less I hear about the Russian space program, the better it's going. Yeah, Lump, I really stopped covering it. I stopped covering it because of this. I don't want to. I'll just keep going with what NASA's doing. We'll just keep going that way. Yeah, I don't know, Nova. Who knows? What about Luna 25? They have the rocket ready to go for it, Core. The Soyuz is ready. I still read about it. I just don't cover it. Yeah, Luna. That I should have said that. I don't cover what's going on stream, but I still read about it. Luna 25, an unmanned lunar probe that Roscosmos is launching, is basically teed up at Vostochny and ready to go. But yeah, people don't want to talk about that. I mean, yeah, Bear knocked that. I didn't think it needed to be said out loud, but yeah, that's the reason why I'm not. That's kind of, I thought that was kind of given information, but I guess it needs to be said. You know what I mean? There's a JAXA lunar lander launching soon too. Yes, that and Chandrayaan 3 from the Indian space research organization is circularized around the moon, and it'll keep doing using Oberth to get into low lunar. Yeah, Chandrayaan-3 is circularized around the moon. They got there, which is good. That's good. How is it when the Raptor engines are failing on the test fire after so much testing? For early this time. Flow issues. Here, let me switch to the Space and Rocket Review for a little bit. We do got to get back into Star Raker though. EJ's Space and Rocket Review. Yeah, Corey, you summed it up pretty straightforward. So, Journey, they have a lot. Long story short, firing on a test stand isn't firing it attached to the booster. That's two different things. The plumbing for the booster is much more complicated. I would be inclined to say, and I know Erudite just posted a link that kind of speculates as to what happened, but I would still give you this answer regardless of seeing what was linked about, you know, them having problems with it. Journey, let's just think about it logically, all right? So they fire them on the test stand all the time. The Raptor engine's gotten very mature because SpaceX is testing them multiple times every day, right? So why are they having problems when it's attached to the booster? Well, they're having problems because, great, your rocket engine works fantastic, but you have plenty of tests on the rocket's turbine machinery and it working and the rocket engine working and getting the rocket engine to work correctly, but guess what? Attaching it to the test stand's not attaching it to the booster, now is it? They don't have a lot of data about it working with the booster.
Discovery, go at throttle up.
I think it's very interesting because I see a lot of, on Twitter and stuff, I see a lot of people say, oh, SpaceX got to solve their reliability problem. They got to solve their reliability problem, which is interesting because they're conflating Raptor reliability with booster reliability, which is, that's weird. That's like saying, oh, I blew a tire on my car, I got a flat tire, I need to put a supercharger on my engine to get that tire more reliable. That's a little strange, right? That's a little weird. They have a lot of testing with propulsion with Raptors themselves, but not with Raptors on the booster. Firing 33 engines is complicated. That is a complicated thing. Think about it. Think about what happens when all those Raptors start sipping out of the propellant tanks through the straw. They all start sipping through the straw at the same time. You have a manifold that splits 33 times. You can create a nasty siphon effect and actually vacuum pressurize the line if you're not careful. All those Raptor engines pulling all at the same time can crinkle freaking pipes from the inside out. They can implode. We know because that happened. Not for that reason, but that's just one of 1,000 things in this complicated kind of ballet that you need to start up 33 motors like that. The other thing to take into account, Journey, is that we don't know if those engines were prematurely inerted by SpaceX before they went for the static fire, or if they went to fire all 33 and the computers shut off 4. We don't know. We don't know which one it is. Well, that's going to take time. I don't mean, maybe unless Elon posts about it on Twitter or something, or X or whatever, we might not ever know. Hey, Nico, 54-month resub. What's going on, buddy? I'm asking if you have an idea why reliable engines are failing on the booster on the OLM. It's because of something that hasn't been tested on the booster in the OLM, dude. Yeah, I mean, that's it. That's what I'm getting at, dude. Yeah. Thanks. SpaceX said they turned off early, so they must have fired. We don't know if turning them off early is them turning them off or the computer saying no. Shifted to preferring Zitter. I still like Twix, but yeah, I think either one is equally valid. Still has more testing than the N1. Did the OLM get redesigned after IFT1? Partially, with the deluge system, Nova. Yeah, sure. I like Twix pipe, though, so I'm going to call it Twix. Seems like a lot of people don't think about Starship being in testing still. Like they got the achievement and then it realistically figures itself out. Yeah, exactly, Core. It's going to take some time. In that case, the X pronounces SH. It's a little bit of a stretch, don't you think? I understand what you're trying to say, but they also upgraded the Raptor quick disconnect arms after the IFT. So, you know, it's pad stuff, dude. I thought the Spin Prime would have detected the issue. Obviously, it doesn't. Actually, that's a pretty good point, Journey. If this is something that they didn't detect during the Spin Prime test, so the Spin Prime test proved green, so they proceeded to static fire and 4 engines shut off. Well, that tells me that you might be onto something, dude. Tells me that something is weird with the igniters. Now, let's think about this for a second. How does Raptor ignition work? Well, there's igniters in the pre-burners. We know that. But what actuates the pre-burners? Well, on the inner ring of engines, on the inner 10 and the inner 3 engines, so the center 3, I mean, no, they might all have the same ignition system, don't you think? Or I think the igniters on the outer ring are actually ground side to save mass, whatever the ignition system is. So, Journey, I think this points more towards GSE, less towards booster, more towards ground servicing equipment, but it could still be the booster. It depends on what engines failed, right? Like, that really depends. Igniters are the same. The outer ring has N2 supplied for the spin-up, supplied from the pad. Interesting. There are different igniters. Some of them can be relit in flight then? I'm not sure, Nico. I think Core is right that okay, so think about it like this. You know, you have a car with an internal combustion engine. You start it, right? And then it turns on, right? The starter motor isn't the spark plug, okay? So rocket engines have a starter motor, and then the igniter is the spark plug, right? So now that I'm really thinking about this, all the igniters on the engines would be similar, but the starter motor is going to be different. Rocket engines, because they use a turbine on a turbo pump system, in this case, Raptor's using power heads or pre-burners, right? Pre-burners have a turbine that spins an impeller. So you gotta get the turbine spinning. So it's a pneumatic thing. You ever take like a compressed air and take it up to a computer fan and go that's how they fire. So I suppose if it's the inner 13 engines, so the inner ring of 10 or the center 3, then something is weird with the starter motor on those. But if it's the outer ring, then something might be weird with the pad. And we know they did upgrade the pad over the last couple of months since IFT. We know that they changed it. They changed the quick disconnects. So something tells me that it's not necessarily the igniters, but the starter actuation system, which is a pneumatic system. It's nitrogen. They spit nitrogen into the turbines, and that gets the turbo pumps ready to go. They start pumping, and then they switch the igniters on or whatever they're using for ignition. Yeah, super interesting. Good logic exercise, fellas. Yeah, that tells me that something with their actuation system. Something with their actuation system. Basically, if you don't get the turbines on Raptor spinning to the proper RPM for ignition, you could create what's called a hard start scenario, basically where the rocket engine could backfire or it just peters out. It'll just go, or you'll have a detonation inside of the combustion chamber, which, yeah, that's bad for it. We'll just say that's bad for it. It peters out. You don't want a rocket engine to do that. Isn't that what the spin prime test is for? So Journey brought that up, Mutter. Journey brought that up. If that data didn't show in the spin prime test, then you went to do the static fire and got a different result. Did somebody change something? Somebody change something? Were configurations changed between the spin prime and the static fire yesterday? Space news. Ooh. Yeah. I don't know, T-Man. I have no idea. I think there's some validity on the supposed insider information. Yeah, but I try to avoid speculation. I mean, we think about it logically. I mean, and the logic kind of points to what you're saying, but I won't report that. You know what I mean? So yeah, guys, I honestly think that the Raptors aren't the problem, because if the Raptors were still the problem, that would mean that McGregor's testing regime is pretty crappy, right? That would mean that it's pretty bad. You didn't test it right. I'm thinking it's some other thing that's not the Raptors. So, booster design is constantly in flux. Look at Booster 7 versus Booster 9, right? That's totally different, right? And the pad design is constantly in flux too. The pad design has changed. The Deluge plate is a good example. Pad's had some drastic changes. So, as we see more tests and more design comes into, the design, the iterations and changes on the design get smaller and smaller over time, there will be perceived Raptor reliability happening, because the systems that make them go are going to be more matured. I mean, I guess it's speculation on my part, but I honestly think this perception that Raptors aren't reliable is a little strange. I see people bring that up and I go, how can you say that when they fire one like on the test stand every 2 times, 3 times a day? That's really funny to me. We also don't know if they We also don't know if they went for the full 33 engines on the spin prime. All we know is that it seemed like a lot of engines. Yeah, it was really hard to tell. With that deluge system, it's really hard to see. John did say they were doing different engine start procedures at the start of the cast. There you go. I agree that it makes sense. It's an integration issue, especially with that failure percentage. Yeah, I mean, I don't think it can be understated how insanely difficult it is to get 33 engines to fire near simultaneously. That's in terms of rocket science, that's up there. That is an extremely hard problem to solve. That's a really difficult thing. I'm trying to figure out, I'm trying to think, Nico, what is something that's equal to that in terms of difficulty in spaceflight? Maybe landing on the moon? That is really difficult to get that right, especially with the complicated plumbing of Raptor. Well, I wouldn't say complicated plumbing of Raptor. Raptor's plumbing has gotten a lot simpler over the years, especially with the move to Raptor 2. The combustion cycle, with that stage combustion, that's an extremely hard problem to solve. But it seems like the ignition, the actual rocket engine components aren't the problem right now. I think that it's very much pad the pad and booster design being in flux. That's what makes the most sense. Closed loop life support? Yeah, I don't know. I mean, that's a hard problem to solve. You have to stagger your ignition of every single engine. You can't fire. You might be able to get away with firing like 2 at the same time, but for the most part, you have to fire every engine like a millisecond later, and staggering the ignition like that means that you have to get the plumbing all working before the first ignition happens on the rocket engine, or else you're going to get a siphon effect to whatever rocket engine is on and whatever rocket engine is off, right? And remember, you have a manifold that splits 33 times. The fuel manifold that splits 33 times. Fuel and oxidizer manifolds that both split 33 times individually of each other. That is some complicated plumbing. So that means all the engines have to be basically flowing, have a flow rate that is prepped for ignition all at the same time. And when you fire one, right, you have to make sure that that one doesn't start sucking all the freaking fuel in one direction. I mean, I might not be looking at this right, but if I understand how pressure and manifold distribution works, if you get a pressure drop from an engine firing and sucking in more fuel, right, you're going to get a momentary drop in pressure on the pipe and the plumbing that goes to that engine. Oh, that's complicated. That's whoa. I had to go eat dinner. What happened to the build? Kix did a Space News segment. Starliner had a press conference basically saying they solved most of the problems that they were running into with it, and they should be ready by March next year for a crewed flight, which is good. That's good news. Man. Just imagine splitting your garden hose 33 times with exactly the same output. Yeah. I mean, they primed the system, Orion, but yeah, I mean, that's not even, I'm not even thinking about like thermals. A momentary drop in pressure in the pipe, even if it's for a fraction of a second, could shock load the pipes and break them. I mean, that's what happened on the N1. Like, well, the N1 had turbine ingestion. Long story short, the propulsion wasn't the problem on the N1. It wasn't the engines. The engines were a great design. It was the plumbing. Plumbing's hard, man, when you fire that many motors. Jeff Bezos' Blue Origin is a work-from-work company, says leaked email tightening office mandate. With rockets, I kind of agree with him on that, Snick. Is that bad? Rockets are already a complicated thing, and you're complicating it even more by like remoting your workforce. The one exception would be software with rockets, I think, because you already have to communicate through a computer as a medium when you're working on software. But then again, one could make the argument that for design you have to do that too. But like manufacturing, like how are you going to manufacture a rocket from home? You can't take ITAR home with you. That's another good point. Hard to disagree. Why would an IT technician, for example, need to be in the office? IT, yeah. No. Grab Shark, IT, yeah. Go work from home. If it was me, that's how I would do it. Why do you need to be in the office? It's a good question. Get the frick out of here. I'm talking about like the people that build and the people that design. I think that the design teams and the technicians, obviously the people that put the stupid thing together, they really can't work from home. But it'd be good to have all your designers probably under one roof. I would want that. Not the entire company, though. The entire company, if it's for the entire company, I agree with you. Yeah, good. Have fun with that. I need to be in the office often because people need help. I think Ando, simultaneously, kind of contrary to what Grab was saying, I do think there is a need to have in-house IT as well. You know, remote IT work is not fun. It's really difficult to troubleshoot a computer when you're not the one using it. That's hard to do. You ever been on tech support with somebody from overseas or somebody that's not next to you? That's really hard. Heck, IT is hard enough when trying to fix somebody's computer when you're there. But yeah, I don't know. Maybe an on-call IT service, Grab, like doctors back in the day. Doctors making house calls, IT people making it. That's a really good idea. As an IT person, I strongly disagree. If you have well-built systems, you can troubleshoot almost anything remotely. Anything less, and the company hasn't paid up for good enough systems and infrastructure. That's just Geek Squad. Yeah, I'm talking about Geek Squad, but Geek Squad that doesn't suck. So, Grab, my question to you is this. So, well-built systems, and I'm not an IT guy. I can rebuild a carburetor. I can work CAD systems, right? So, I mean, I'm sure I could figure it out. But these well-built systems, who maintains these well-built systems? I'm talking about physically. Like, where do these, what is a well-built system, and how often would you find that at any particular tech company? I'm picking your brain. I'm not trying to make a point. I can answer that. Third party. Okay. Tons of remote monitoring, remote access to remote machines, things like that. You'll ship out a new laptop with a new employee preloaded with a VPN, remote desktop, all kinds of stuff like that. You can automate a lot of it, and then remote tools solve the rest. Okay, Grab, another question that, another thing that Wisp brought up. Do you think that that jives well with ITAR? Like, think about that from an ITAR standpoint. Like, if you had strict adherence to ITAR, like, do you think that remote VPN, remote work thing would be a good idea? I'm actually asking your opinion. I'm pretty sure you're going to say yes, but I want to know why. Hey, Jolks, how you doing? Nice beard. Oh, thank you. Second rate, your wife does ITAR work remotely. Okay. Guys, I actually am not trying to make a point. I'm trying to learn. Just thought it, you know, like usually I ask questions like this and I'm going somewhere with it. I'm not going with it. I'm wondering. Here are the exact words from John during the cast. All right. Give me 1 second. I gotta find the mouse. Where is it? There it is. In that time, the team worked on multiple improvements to the booster as well as pad systems and infrastructure, which we will be testing out today, in addition to a new startup sequence. Yeah. Okay. It's definitely something with the starter motor on the engine's animal. I think that kind of seals the deal. Yes, the company I work for, Remote Geek Squad, but actually good, has to set up our clients' networks for tons and tons of very highly controlled environments. Lots of medical HIPAA stuff. We have tons of ITAR clients with remote employees. Which probably wouldn't be an issue, but anything with clearance would be more difficult. Most of it has to do with data security, endpoint protection, strong VPN, things like that. ITAR from an IT perspective is much easier to deal with than things like HIPAA. If the virtual machine is at the server and the remote is streaming input output only with no local storage, probably fine for ITAR. That's how many places manage HIPAA. Yeah. I heard you talking about CAD. Do you use HAD and SolidWorks, and have you heard of SolidWorks? I've heard of SolidWorks. I'm not proficient in SolidWorks right now. Clayton, give me a week and I'd be proficient in SolidWorks. Arian Rod, okay, security architect here. I build FedRAMP high systems for ITAR clients. Yes, it's possible, but it's a pain in the butt. Okay. So GrabShark, this sounds like...
Discovery, go at throttle up.
This sounds like the ever constant battle between what your company needs and what upper management can fund, or what upper management thinks it needs. That's what this sounds like. You know, if anybody here is a developer, I hear these stories all the time from Bree. If anybody here is a developer, your boss says, "Oh, what would be the ideal system? What does our software need?" And you tell them exactly what they need, and they say, "No, we don't have the budget for that." You just asked me what you needed. It's always worked. We've always done it this way, so why do we need to change it? Oh boy. Yep. Okay. All right. That's the root of that issue. Got it. And they're knocked in. That's why I stopped doing it. Sounds like Congress keep it. Yeah. Oh boy. You know, GrabShark, that sounds like a big poop sandwich. I didn't realize you liked eating poop sandwiches. But I suppose if you get paid to, then, you know. As someone in an accounting department, I'll never run into an IT department with a budget problem. I've never run into an IT department with a budget problem. Yep. Interesting. Yeah, Moist, I got you. It took me a second. Dude, I can't tell you how many times we pitch to a client that they absolutely need to update this one thing. They say no because of money, then they get a data breach and complain to us and then blame you. We point to all the times we ask them in writing to upgrade, and their refusal, they end up paying much more to remediate the consequences of their action. Oh boy. Google is giving discounts to $99 a night for their paid employees to come back to campus. Interesting. And also, I can discover issues when I talk to users directly. I still think, yeah, face-to-face makes it easier, for sure. Just another level of support. Looks like Ford won again in Michigan. Neat, Bandit. As for how someone would reboot servers, press buttons remotely. No, I got you. Okay. So platform management interface. Intelligent platform management baseboard management controller. These are words that I don't understand, Aqualex, but I'll take your word for it, man. What is the next overpressure warning for Boca? I'm not sure off the top of my head. Oh, nice, Thomas. Yeah. The Edison L750 mod is coming to ATS. Neat. Yeah, they took the booster off the pad journey, so it's not going to be for a little bit. Anyway, next little bit of space news here. Good discussion, guys. I just was wondering. Yeah, I mean, like I said, I would want my designers, if I was running an aerospace company, I suppose if we sprung for a nice IT system, which, you know, I'm not the budgeting department, but I would certainly make that a priority, right? Like, say, you know, in the context that we sprung for a nice IT system and had some remote, I would probably still have people come in from time to time, just like maybe on an on-call basis, you know, like, hey, can you come look at this? Like, can't do it remote, come here. But I still think, like, having the designers of the rocket and the people that obviously build the dang thing, yeah. I mean, that there's really no getting around that. I wouldn't want design to be done remotely. I would not want that. I don't think that's a good idea. Think a Raspberry Pi built into a motherboard yet entirely separate from it, wired into the buttons and other sensors on the board in parallel to the rest of the board. Oh, interesting. Alright, Phil, we got 2 there coming from Stephen Clark for Space News. Let's see. I still have the other 2 queued. Stuff like embedded systems like avionics, you need hardware to interact with. Yeah. Oh yeah, that's all I do now? Really, Rocket? Jeez. Avionics department, yeah. I mean, Rocket Guy, to be fair, avionics fascinates me. Like, the missile knows where it is and whatnot. That's actually... Like, every once in a while, dude, like, I'll get introduced to a new, like, thing with engineering, and either it clicks or it doesn't. Like, electrical engineering didn't really click with me for a long time. And then I wired the truck. I wired the 59, and now I'm like, oh, okay, yeah, you see it. Like, you know, you have your strengths and weaknesses. Some things click right off the bat, other things don't. They take time. With that being said, like rate controllers and stuff and PIDs, that scratches the itch, you know what I mean? Like, I'm like, yeah. So, yeah, that's super cool. Super cool stuff. What is this a picture of? D-Man. Gateway, power, and propulsion module. Let's take a look. Oh, there's the core of the PPE. Cool. All right. That's a tube. So the satellite is built around this tube. It's like the internet. This is your payload attachment fitting, so it would be attached down here to the rocket. And then the satellite bus that the PPE is built on allows for stacking satellites, so the top of the satellite has a payload attachment fitting on it as well. In this particular case, that attachment fitting is for the habitation and logistics outpost. So they're stacking a crew module on top of a stackable satellite, which is cool. And that's all going to go in Falcon Heavy eventually. Neat. So this news right here, Astra lays off, reassigns employees as it refocuses on satellite propulsion. Interesting. This is a Space News article from Jeff Faust. Astra announced on August 4th it has laid off a quarter of its workforce and reassigned others from launch vehicle to satellite propulsion development as its cash reserves dwindle. Not itself, but designed to integrate into an ESPA ring. Looks like it. Yeah. There's another adapter in there, Rocket. Yeah, because you're adapting NDS to whatever that satellite bus is, right? Astra's done their barely selling propulsion product as is. I'm reading the article. I just want to see what's going on here. We are intensely focused on delivering on our commitments to our customers, which includes ensuring we have sufficient resources and adequate financial runway to execute on our near-term opportunities. The layoffs and reassignments. Hey, Ray, thanks for the raid, buddy. Just reading some articles here. You guys know my buddy Paul Scambaits. He does Scambait streaming, where he scambaits freaking scammers, which is pretty awesome. Hey, May, can we get a shout out for Ray in the chat, if you could? If you guys like Scambait streaming, Paul Scambaits is good. He's a good one, really good one. I love watching. I get very much enjoyment out of scambaiting scammers. That's very nice. But anyway, thank you very much for the raid. I do appreciate it. It sounds like Astra is trying to pivot here, guys. It sounds like they're trying to pivot. Yeah, this doesn't sound like Astra's necessarily done. Yeah, Rock Guy took the words out of my mouth. Honestly, typical startup pivot move. It's great to see for a startup company of Astra's size, though, but you got to focus on what gives revenue to survive to the next big break. It sounds like they're trying to pivot because they don't have enough cash to see Rocket 4 through. It does happen. Twitch app is broken, Iron Spark. The uptime on this stream is 4 hours and 9 minutes. Yeah, I don't think that Astra is necessarily done. We'll see how this pivot pays off. A lot of startups often pivot like this. They, you start doing one thing and then you figure out that another thing that you can kind of move some of your workforce to could potentially be more profitable, and then you kind of put whatever you were working on initially as the back burner. Initially, Astra basically became a thing because they were working on a DARPA contract to be able to launch anytime, anywhere within 24 hours of a launch request. Basically, DARPA, the contract for DARPA was basically saying, you need to be ready by this date. We're not telling you where the launch site is, and we're not telling you what we're launching into space. We're telling you the mass of the payload, and that's it. And your rocket has to be ready. Basically, orbital launch capability from anywhere. The cool thing is that Astra developed a GSC, a ground system and rocket system that can be entirely transported inside of intermodal containers. The entire launch pad can basically be packed up into 2 or 3 Connex containers and moved anywhere via truck, which is actually really cool. It's a really interesting system. But they didn't get that. They were on contract to make it work, and if they had been able to launch anywhere at any time, that would have led to more contracts within DARPA, but they didn't get it. They didn't meet the criteria. So since then, Astra has farmed around their rocket for other contracts and has had NASA contracts for a Tropics satellite, but that one actually failed too, amongst other things. They do seem to run into a lot of bumps in the road with their design. The DARPA Launch Challenge loss was really bad for Astra. That was their short to midterm business model. Bingo. Yes, I nerd. On top of, hey, building mobile GSE is difficult. Who knew? They should license that to something like Rocket Lab. The stipulations for the contract, Oculus, were that the pad is as mobile as the rocket. You can launch from anywhere. Anywhere you could get a Connex container, you should be able to launch. So yeah, I do grab. Yeah, right. So it seems like they're pivoting to satellite production and putting launch vehicles on the back burner for right now. Sometimes if you don't retain technical expertise, you gotta cut it to keep the business going, which sucks. But hey, hopefully this isn't indicative of a potentially contracting commercial launch market. that would be extraordinarily bad. I don't think it is necessarily. Chris Kemp's quote isn't exactly inspirational, though. What did he say? We are intensely focused on delivering our commitments to our customers, which includes ensuring we have sufficient resources and adequate financial runway to execute on our near-term opportunities. We have to deliver on the stuff that's going to make us money to keep the company alive. Got it. I mean, the mobile pad tech to someone be with a small launcher. Yeah, maybe. If Rocket Lab was interested, but I think even Rocket Lab is pivoting away from a small sat launcher. Rocket Lab, what Rocket Lab originally envisioned Electron to do is nowhere near where they're going with like Neutron and stuff, which is interesting. This is where I say that Peter Beck is insanely smart with diversifying Rocket Lab so much. If the small sat market collapses, they do launch service, build satellites, provide hardware for sats, mission planning, operations, software, and more. It's really end-to-end with them, Phil. Yeah, really smart. Yeah, Peter Beck saw it. He saw the writing on the wall. You really want to make it sustainable, get your fingers in more pie. Firefly is doing the same thing. Firefly was doing that before Rocket Lab, if I'm remembering right. Remember like 2018, 2017, Firefly was talking about being the commercial off-the-shelf provider for like parts, for rocket engines, for fuel tanks, for plumbing, for pipes, for pad service equipment. Firefly was the first time I really got wind of it. But don't get me wrong, maybe Rocket Lab was doing the same thing, but Rocket Lab was the first one to do it. Firefly hasn't pivoted as much. Well, not pivoted, but yeah. Now it's Ursa with engines, which is cool, but they have been downsizing too. Just keep your fingers out of my pie. It's mine. No, it's mine now. I bought it. Didn't Firefly also score a major contract with Northrop Grumman to make the engines for Antares? Well, there you go. That's what I mean. Outsourcing their engine design and becoming basically a parts shelf for rocket parts. Smart. Very smart. Hi, Pie Guy. Firefly is also kind of grounded since they are still waiting on the DoD to give them the call for the 24-hour call-up mission. Isn't that what Blue Origin is doing too? Kind of, Bandit, yeah. Blue is more... Yeah, I mean, Blue is expanding into all different types of things, all different types of contract, from propulsion to launch services to building landers to... They're kind of doing it, but on a much bigger scale than like what Firefly or Rocket Lab is doing, because they have the financial runway to do it on that big of a scale. You understand what I'm saying? Everyone's been downsizing. Yeah, but Signer, this pivot with Astra is not necessarily because of market conditions. I think this pivot is, I mean, it could be because they might not have been able to get the venture capital that they were looking for, but this pivot, I think, was coming before, when they had a rocket fail a bunch of times. How will LK-99 change the space industry? Ravengard, if LK-99 delivers on what it says, building electronics for spacecraft is going to become a lot easier. Yeah. Superconductors in space could work from, could have benefits anywhere from, simplified electronics on satellites all the way to high throughput electrical propulsion systems. Yeah. But with that being said, I don't really want to talk too much about LK-99 because it hasn't been peer reviewed. So basically, until it's been peer reviewed and until we absolutely know for a fact that this is a thing, I don't want to speculate. That, and I don't know dick about superconductors. That last part was kind of a big one. Yeah, Aqualux, but it's very interesting. If everyone's trying to be available in the parts market, who the hell's launching? That's my question. If everyone wants to be this off-the-shelf provider of launch parts and be the one that provides the parts and doesn't take the risk of actually putting a rocket together and launching, what's the point? Yeah, well, the internet got hold of it, Synerd, so I don't know why you're surprised in that regard. I've been reading about it, Aqualex. It's just not one of those things that's clicking in my head. I don't need links to another channel that's just going to sit in my back burner of queued videos that I have to watch, and I'm gonna forget about it. You know what I mean? I got to do it on my own time, dude. I got it though. Yeah. It's just interesting to think about, dudes. Anyway, let's go to the next bit of news. Even SpaceX pivoted a little by making Starlink, but Starlink was there to give a constant demand for a launch market. God, it was there to give Falcon 9 a job. Because even SpaceX knows that having being able to turn around a rocket in 4 days means nothing if you don't have anything to launch. Starlink was the means to the end of solving that problem, which is actually super freaking smart. That's a really smart move. I'm not necessarily sure I'd call that a pivot, but I do understand what you're saying. And you are absolutely right. Do we think it's because SpaceX has changed that market because their prices just can't be competed against, so people got to pivot to other areas? Possible. The standard startup business model is to start small and get bigger. Most satellite providers started as just a component provider until they can get to a point to go for the bigger version. Large launch vehicle startup companies can only do it with large initial seed funding investment, which is fairly rare. Yeah, no one wants to stake that much money on the line. I'm just saying that it seems like everybody's failing to temper their expectations. And I'm going to end up one of the few people not disappointed. That's why I'm not talking about it, Synerd. I'm kind of with you on that one. All right, next bit of news. What is this? This is coming from Stephen Clark. Here. Really? Stephen went to ours? Interesting. Amazon confirms it now plans to launch the first 2 test satellites for the company's Kuiper broadband network on a ULA Atlas V rocket as soon as next month, shifting the payloads off of the inaugural flight of ULA's Vulcan rocket. Okay. We'll use an Atlas V 501. All right, cool. Yeah, So the reason why they're doing that, guys, is because ULA figured out a potential failure mode in the Centaur 5 upper stage with a certain style of mission that put extraneous load on the forward dome of the Centaur. So they found that in certain conditions, under certain circumstances, with certain missions, that the Centaur tanks can literally pop like a balloon. Funny story, they're called balloon tanks. They're very, very thin. So ULA found this problem in testing, which is right. That's what they should be doing. And that moved Vulcan's schedule a little bit. Once again, this is just one of those bumps in the freaking road. It's one of those bumps in the road that happens with aerospace engineering. You're always going to run into something like this. It always happens. Every single project without exception. So it seems like they've switched ULA in order to make sure that they're fulfilling their needs to their customers. They've shifted it to an Atlas V. I would also say that Project Kuiper and Amazon has bought 9 Atlas V. They have 9 Atlas Vs ready to go for Project Kuiper. So pivoting like this is just a no-brainer if Vulcan's going to take more time. The picture they chose looks like city skylines, but with rockets. Yeah, it kind of does, Tempest, doesn't it? I'm interesting if there's a. I'm interested to see, not interesting. I was gonna say it's interesting. Amazon originally intended to use its 9 Atlas V missions to deploy operational satellites, with several dozen flying on each rocket. Now Amazon will use one of those Atlas Vs to launch just the first 2 Kuiper test platforms. All of ULA's remaining Atlas V rockets are already sold to customers, so there's no opportunity to build more. Okay. Did SpaceX get their test done yesterday? They did, Rollo. Yeah, it was an awesome test. Static fire. It went okay. They had some problems, it seems, with igniting the engines, but the deluge system looked great. Amazon has not revealed much about the design of its Kuiper satellites, other than that they are 3-dimensional in shape, not flat-packed like Starlink. Each Kuiper's spacecraft likely weighs a few hundred kilograms at launch, so a dedicated Atlas V launch into low Earth orbit for just 2 of the satellites is a bit of overkill. Compared to what? Vulcan? It's a weird thing to say, considering Vulcan's a more powerful rocket. They were ride-shared on Vulcan. Ah, okay. No, that's not a weird thing to say. Got it. Yep. Okay, cool. I was wondering, I'm like, more powerful rocket. What the heck are you talking about? But that makes more sense now. This Kuiper launch will also use a temporary license to allow for the 501 configuration, as ULA pulled all but the 551 configurations licenses. Interesting. Amazon apparently thought it was worth expending one of the Atlas V rockets it has under contract, allowing the company to get its satellites into orbit sooner to verify their performance before proceeding into full-scale production of Kuiper spacecraft. Amazon needs to deploy half of its 3,236 satellites by July 2026, a deadline to maintain network authorization from the Federal Communications Commission. That would require at least 2 launches per month beginning next year, and perhaps more from Amazon's stable of launch service providers. I never realized you never realized Atlantis until I stood next to it. Well, I would hope you would realize that it's there. It's kind of big and hard to miss, public. These 2 Kuiper satellites were also originally launching on ABL RS-1 rockets, but delays put them on Vulcan and now on Atlas. Interesting. You've never seen a shuttle up close till today? You live in Florida and you never saw a shuttle up close until now? Alright. That's a little strange, but yeah. Big, isn't it? A lot bigger. Your brain has expectations for how big you think a shuttle is, and it's always just a smidge bigger than you think it is. It's huge. It's a big vehicle. That thing went to space and back. 33 times, dude. You see why I like the shuttle so much? That thing came back from space. Okay. Yeah, alright. Is Amazon going to launch them from West Texas, where Blue Origin is? Blue Origin's suborbital rockets launch out of Van Horn, Rollo? these rockets, these satellites will be launched from the Cape. Even when Blue Origin gets New Glenn operational, it'll still launch from the Cape. Launch providers don't like launching inland. One, because you kind of have to worry about debris falling on people. There's a lot of populated areas to the east of Van Horn, Texas, like Houston, and Austin, and San Antonio. You don't need debris coming down over there. That's probably a bad idea. Maybe we could get to the point where, launching and landing boosters is so reliable that, maybe they'll launch from there someday, but not in the near future, dude. I just saw my first space shuttle 3 days ago at Intrepid. It's big, isn't it? I could pull up a chair and sit there for hours, still feel like I didn't get enough of that shuttle. Pi, it's big. Like I said, we could sit here and look at pictures of the shuttle all day. You don't understand the scale of that thing until you stand next to it. It is bigger than you think. Amazon got dealt a bad hand, as all of their 3 to 4 contractors, all big Western companies that don't start with S, have major development delays. They're launch providers, Driados, yeah. That's what she said. Oh, why was she talking about a space shuttle, Fahas? Anyway, it sounds like this pivot to Atlas V sounds like Amazon has to get, I think this is the most pertinent thing here. Amazon needs to deploy half of its 3,200 satellites by July of 2026. A deadline to maintain network authorization from the FCC. That is the driving reason why they're doing this. They have to make sure the satellites work. They got to start launching them, and to do that, launch 2 prototypes, make sure that they work, and then start cranking them out like crazy. Can you imagine that sometime in the near future, there will be a Starlink launch basically every 4 days, and there will be a ULA launch, like an Atlas launch or a Vulcan launch, every week? That's crazy. That's crazy. That's absolutely nuts. You'll believe it when you see it. Well, half of that's already happened, but all right. I would rather have New Glenn every week. That is a potential outcome of all this. Your KSP projects will never get done. Whatever. Atlas V with Falcon 9 launch cadence is bliss. It's funny, Zay, because Atlas V is fulfilling a capability that it was engineered for back 20 years ago, but it never came to until now. Interesting, right? Turnaround for 41 will be hard. Not with 2 mobile launchers. You'll be all right. Delta could have done it, Phil. Delta could have done it. But no. I still say that dude, I'm not harping on Atlas V. I like Atlas V. I think Delta is a better design. There, I said it. I will not be taking questions on this. I think that the way that the GSE is set up for Delta enables rapid launching. But no. Oh, launch market had to crash in the 90s. Pfft. All right, Pi. See you, buddy. Saw the VAB up close in the 2 crawlers. They're working Pad 41 structure from when SLS cooked it. SLS launched from 39B, not Pad 41. How's your mother? And the fact that Delta is shuttle derived. Do you think they could have ironed out the constant LH2 leak scrubs with Delta 4? Of course, Synerd. I think that those LH2 leak problems happen from infrequency of launch. I'm starting to go insane with all these Falcon 9 launches. Glad to see we will have more launch diversity coming. Hey, Noswell.
Discovery.
James, tier 2, 76 months. Woo! All right, a little bit more space news and then we'll get going. This next one is also coming from Stephen Clark. What is this regarding to? Oh, this is a response to that same article. It is also worth noting that this launch will utilize Atlas V 501 configuration without any solid rocket boosters. ULA was previously thought to have retired all liquid Atlas V configurations last year, but plans change. Yeah, the FCC deadline for Project Kuiper satellite recertification is what's driving this. But somebody at Blue Origin was smart enough to plan ahead in case Vulcan had problems. I'll take stupid things I've said for 500, Alex. Yeah, it's all right, public. I know what you meant. I was just being a dick. It's kind of my job. I'm from the Northeast. It's kind of my thing. Jeff, where are my rockets stored? How about a 501? Yeah, right? Didn't Ariane 5 start having LH2 leak problems near the end of its lifespan? Launch cadence was slowing down. Yeah, Seinert, it happens. I mean, Seinert, dude, think about it like this. Rocket launch pads are a mechanical system, just like any other piece of mechanical whatever, right? Say you have a car, and you drive the car every day, right? Something's less likely to go wrong, albeit something that you encounter like on the road if you get a flat tire or something, right? But as long as you keep up with the maintenance, with the routine maintenance of the car, it pretty much is going to be 100% reliable every day. Now what happens if you leave that car and drive it once every month? Right? Sitting is terrible for any automobile. Sitting is bad, very bad. A car not driving down the road is not good for it. It's designed to be driving down the road. It's not designed to be parked, right? So you're going to run into more maintenance problems letting it sit. Same exact idea, but with launch pads. Same goes for planes, same goes for trains, same goes for trucks, boats, any type of mechanical system. Letting it sit there and not doing what it was designed to do is going to decrease reliability. It's just this damn oxygen freaking atmosphere that ruins everything. I mean, the breathing part, though, is good. Can we keep that? How's your spaceport, Northie? Oh, wait, you don't have one. That's not your spaceport. It's the U.S. government spaceport. Atlas Heavy. Nice. Nice, Thomas. Come on, come on, ULA. I know you want to. Same with humans. I mean, I don't know, floating, if you technically classified the meat suit as a mechanical system, but also, yeah. Any news on Chandrayaan 3? Ronnie, it's circularized around the moon over the weekend. So it's going to take some time to lower its orbit around the moon, but yeah, keep you updated as I see, when I see updates. I keep you updated as I see fit. Oh, my brain. Sometimes, I swear. So if you didn't see what happened over the weekend, here, look at this.
Today's test. New system aimed at protecting the pad against the immense heat and force of a Starship launch. Today's test is to static fire the Super Heavy first stage. We are not looking to lift off today. That means the engines will not throttle up to full power. That would happen after a liftoff. But even at the power of today's test...
Woof! Look at all the thermal protection that they have up in there now. That's crazy, dude. That's a lot of TPS up in there. They did helicopter on Mars? Can confirm. Letting a hangar queen out onto the flight line can feel like you're trying to run a race the wrong way up. One of those airport people movers. Yeah, it's terrible for airplanes, Aqualex. Yeah, you know that, dude. Can I just...
A water deluge system.
So this is yesterday. This was yesterday. I covered the cast on NASA spaceflight, actually. Yeah, they had me go over there and cover this with Das. It was fun casting stuff with Das again. That made me happy. And Adrian and Jack are great commentators too. And then Chris B. What else can you say about that guy?
We will have more thrust than Falcon Heavy does at full power during its flight. Now, from start of ignition.
Yeah, and it's starting to look like a spacecraft, right?
Today's test will run just under 5 seconds.
Damn, boy, dick!
Prop load started at T-minus 67 minutes. Now, while we're fully loading LOX today, we're only doing a partial load of the methane fuel, just enough to support the short test. You may notice frost over most of the LOX tank, but just a portion of the methane fuel tank.
T-minus 40 seconds.
We've heard the announcement for Flight Director. We're past the 40-second hold point if needed.
T-minus 30 seconds.
So once again,
30 seconds.
This
Let's
was
listen
yesterday.
in to the last half minute of the countdown of today's static fire.
This was yesterday, guys. Yeah, we saw
T-minus 20 seconds.
with the pad deluge system, we saw engine ignition, which was really freaking cool.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
That's a lot of steam. Fencing. Yep. There's so much clouds down there, they made South Texas look like the Pacific Northwest. Look at how hazy it is. I've seen it, Ronnie. Yeah, great movie. What a beast. Did anyone say any more about why it had to abort after 3 seconds? Okay, so Joe, yeah, here, let me bring everybody else up to speed here. Okay, Thomas, hold on. What's that? SpaceX also had a slight issue with one of the SPMTs. The left rear, one of them suddenly dropped to the road surface while driving down Highway 4. They did a quick check of hydraulic fittings and then re-leveled it before the roll continued. Don't forget about the ear piercing. Yeah, the vent noise. Yeah, we got to get the decibels figured out with those mics. Was there any pad damage? Blackbird, no damage seemingly. That doesn't, just because we can't see anything wrong with it doesn't mean there isn't anything wrong with it, right? But yeah, no, it looked okay. The deluge system seemed to do what it wanted to do. So, or do what they wanted it to do. Now, let's, woof. Okay, so let's talk about this. So, SpaceX had planned for a 5-second 33 engine fire. They got a 2.74 second 29 engine firing. Not bad. Not exactly what you want, but not bad. Some of the engines didn't go. We can kind of speculate as to why. I think it has something. The long story short, we did talk about this a little bit earlier on the stream, but the short story about, the Raptor engines not going, I think has more to do with the booster and pad design than it does with Raptor reliability itself. I think the Raptors are plenty reliable from all that testing that they do up at McGregor. SpaceX is firing Raptor engines constantly for acceptance and qual testing, and then even then they're still pushing the limits with certain designs of Raptor, right? They have like R&D, they have testing, they have qualification. Basically, qualification is basically making sure that the engine works before they put it on anything, right? R&D is doing Mythbusters things with rocket engines, which is really cool. And yeah, the qualification testing is kind of like the first thing that I said. But we only got 29 out of 33 here, which isn't bad. But that tells me that, we know that they redesigned some of the pads since the last Starship test. The deluge system's probably the biggest one, but that doesn't have a lot to do with engine ignition. There are some redesigned parts on the orbital launch mount, which is this big metal piece that's holding this big metal thing, the thing that holds the rocket. There are some design changes, and we know that Booster 9 is not Booster 7. The design of the booster and the pad is very much in flux. So if I had to guess, it's just a guess, if I had to guess, I'd say it's something with one of those systems and not necessarily with Raptor, why they didn't get all the engines firing. Now, that's not all the engines firing. Now, in terms of engine ignition, or in terms of the duration of the firing, they were aiming for 5 seconds and got to 2.7. Why didn't it make it all the way? So, I think that, once again, this is speculative. This is a guess by me. I don't know for sure. It was a guess, but it seemed logical. How did you know that a reactor leak was false? That was a guess. So I'm guessing here. If I had to put my hat into the ring, not this one, I like this one. Maybe we could put that one there. It doesn't matter. I would guess that they are probably using very conservative engine parameters. So what does that mean? With the systems, with the control systems for a rocket, so the avionics, when you're trying something new, you get very conservative with what you're going to allow your rocket engines to do. The idea is to get a good baseline. So, say, like, I'll just use a random example, right? This does not have any correlation to Starship or anything like that. Say you're testing an engine, right? The first time you test your rocket engine, you want your rocket engine to have like 100 bar chamber pressure, because that's what you aim for. You want it to have 100 bar chamber pressure at 100% throttle, right? So basically, pretty high pressure combustion chamber, right? Actually, that's kind of mid-tier at this point. That's because Raptor is skewing that, but that's another story. Say you want it to be at 100 bar, and then you go to test it. When you go to test it, you want the sensors, the pressure sensors that are on board there, looking at chamber pressure. If you're testing for 100, you would want to make sure that you're really close to 100. The abort criteria would be very small. So like maybe 98 bar to like maybe 102 bar. Anywhere in there is close enough to 100 that, it's going to be right. But say you tell the engine to go and your parameters for chamber pressure are too wide, and say it's 80 to 120 bar, and it comes up at 120, and you hard start and the engine explodes. Well, you don't want that. Your engine's now in pieces on the test stand, right? Because of very lax testing parameters. When you test stuff with rockets, when you go to test engines, when you go to test systems, the first time you go to do that test, or if you change something, your parameters for the test being nominal are very, 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 very small, very thin margin for error. Because you don't want to accidentally do something like blow the rocket up, which we've seen from a lot of finite element analysis over the years from aerospace companies. Seems to be like a really simple thing to do. It's really easy to get the rocket to explode in multiple directions. You want it to explode in one direction, right? So if I had to guess, I don't think that 2.74 seconds out of 5 planned is probably due to very conservative parameters surrounding 33 engine ignition. I'm guessing, even the second something starts going off in one direction, like pressure changes inside of the fuel delivery manifold or something. Like the second it starts going off of exactly what they want, the computer's probably designed to shut it off. Very, very, very conservative testing criteria is needed when you're doing very early testing. Does that make sense? Once again, that is entirely speculative. It could have stopped at 2.74 because the computer saw something that it really, really didn't like and pulled the plug on the whole test. But once again, that might be due to conservative testing parameters, which is what I think is going on. Now, what caused that thing to stop at 2.74 seconds? What caused the computer to shut down all the engines? I have no idea. What I do know is that that's a lot of stuff. there's a lot of stuff going on here, like right in this area here. Maybe not like down here or over here so much, but like right in that area right there, there's a lot of stuff going on. There's a lot of things that can malfunction. There's a lot of things that can have potentially anomalous behavior if you don't use it right. So I'm going to guess that conservative testing criteria with something in here caused the thing to stop. I mean, once again, that ain't some shocking revelation. That's pretty kind of industry standard. That's like like a car. The car equivalent would be like, oh, they did a car crash for this test, and what caused the car to crash is it hitting a brick wall. Thanks for the update, EJ. Like, I mean, yeah, there's all kinds of sensors. Pressure sensors, temperature sensors, vibration sensors, strain sensors inside of this thing. We know that this booster is very, very, very heavily instrumented. Most of the time in early flights, you have backup sensors. You have developmental sensors on top of operational sensors. The reason why is you want 2 sensors telling you what's wrong with the rocket, but you got to test the sensors somehow. Having a second sensor to confirm that your operational sensor is A, configured right, and B, sensing correctly is kind of important. So you often have a lot of what's called instrumentation on this thing. You have a lot of extra instrumentation, a lot of sensors. So yeah, that's important to understand. Also, I think we figured out where those wires were going. We saw a bunch of wires on Booster 9 when they moved it into position, and those wires seem to be connected to something on the GSE, whatever those lines are. I don't know what they are. It looks like a line that's flowing some type of cryogenic. So it could be a methane recirculation system or something, but yeah, interesting to see. There's a lot of stuff going on in those other directions. Let's not forget that. I mean, yeah. You're not wrong. There is a lot of stuff going on over here. Not like down here though, but maybe down there. But like water down there. Those lines are to remove LOX vapors to the LOX pond behind the pad. So it's a scavenging system. Or not a scavenging. It's a scavenging and dumping system, I guess. Trouble with 2 sensors that you don't know which one to believe. 3 is better. Sometimes you have a triple instrumented dread swirl. I guess it really comes down to what it is. But yeah, sometimes. SLS had double redundant sensors on core stage 1 all throughout the vehicle. They had 2 sensors everywhere. The reason why they went with 2 sensors is because the OFI sensors, the actual instrumentation on the vehicle, was shuttle derived. So based off of data from the shuttle program, on flight data from the shuttle program, they could kind of figure out if the OFI sensor was correct. They had the shuttle data to compare to, so they didn't need triple redundant sensors in certain areas. We figured that one out from that whole Engine 3 fiasco. The DFI sensor was malfunctioning. Believe it or not, the developmental sensor was not working correctly, and the OFI sensor was working correctly, and they figured it out by comparing it to the shuttle. Dude, you look eerily similar to people from times past. I have no idea what that means, but alright, sweet. One of the most anxiety-inducing things is figuring out if your data is good or not. Yep. Anyway, it was a really awesome static fire to see yesterday. That was really fun. Really fun to watch, and I really enjoyed covering it with the NSF guys. That was a privilege. I also figured out that some of my explanations on things, you guys seem to be okay with, but YouTube does not. The YouTube chat does not like that. Does not like some of my explanations on things. Yeah. There's a lot more pedants on YouTube than there is on Twitch. Don't get me wrong, it didn't rattle my cage too much, but hey Spoon. I was watching that chat and they were like, some people were like, dude, I saw everything. There were people who were saying all kinds of stuff about me. I saw some guy that says that EJ just doesn't fit with NASA spaceflight. Sorry. It just didn't say anything else. I'm like, that's weird. Thanks for the input, though. And then there were other guys who were like, this guy's explanations suck. And I'm like, okay. You know, some of the explanations that I give are basically regurgitated from like actual rocket scientists, and some of it's from textbooks, guys. Some of it's from RPE, and other parts of it is like from modern engine development or modern liquid fuel rocket engine design. I basically paraphrase the book, and people, it's funny because people are like, oh, that explanation sucks. I'm like, all right, okay. Please put the negative comments out of your mind. Yeah, Storm. Like I said, it rattled my cage a little bit, and then I started asking people here in Twitch chat. I was like, was that explanation good? And then I realized what I was doing, and I'm like, oh, nope, never mind. Can't let them rattle my cage like that. Yeah, I can't do it. Not enough football field analogies. I prefer to use bowling alleys nowadays. Yeah. You like Forza Rockets, I still love you. You made the one cardinal sin reading the YouTube comments. I like the chaos, Aqualux. What can I say? My honest opinion, Pythos, NASA basically doesn't put me in as a subject matter expert for no reason. It's because you like SLS. Yeah, probably. Twitch chat, Spoon, yeah. Twitch chat is tame.
Discovery, go at throttle.
Twitch chat is, you guys are very tame compared to that YouTube chat. Granted, that I think the NSF stream peaked at like 40,000 viewers yesterday. A 40,000 person chat is not a 500 person chat. You know what I mean? Like, I was like, man, that chat's going quick. I was trying to keep up with it, and I was trying to keep up with you guys, like all in one. But man, dude, there are some savage individuals there. But I will say that like 90% of the things that people were saying in chat were good. So, yeah, that's actually pretty cool. I would say that that's a remarkable success, right? Like, you know, there's the bad, right? There's a couple of jerks here and there, but most of the things that people were saying in chat about like my explanations were really good. So, yeah, that's nice. That's a really good feeling, you know. Yeah, Gagan. Oh, dude, it was crazy. It was nuts, man. I almost like the chaos, dude. I like how crazy it is. It was absolutely insane. And I will say that casting on NSF takes a lot more effort than this. You have to keep track of, like, the back channel. You have to keep track of the YouTube chat. I was keeping track of Twitch chat. I'm keeping track of 3 freaking chats, my Discord DMs, and also conveying the subject matter all at once, and also paying attention to the live cameras. Dude, it like 8 hours of that kills you. My brain was paced yesterday after that stream. I'm like, Primo was trying to tell me, she's like, okay, we have this much money in this account to pay for the mortgage. I'm like, sweetheart, you're saying words and they are not registering. I'm sorry. I need to go take a nap. Fortunately, she started laughing and didn't get mad. So, you know, that's good. You know, if you have a wife, you know what I mean. I'm like, you're saying words, and they just don't. Nope. You're a keeper. Yeah. I'd say that ratio translates over to Twitch pretty well. Yeah, Malachi, that tells me that I'm on the right track. Oh, they did not like the sonar explanation for why you spray water at pads, because, you know, sound goes through water, like sound likes going through water. Oh, they didn't like that. They did not. I probably won't make that analogy again. It's a little too general for NASA spaceflight, I think. Yeah, that's pretty normal when you're outside the mic. Yeah. Yeah, I know what you mean. Yeah, like I said, if you know, you know, right? They did not like that one. I probably won't use that analogy again. The sound, water likes to basically absorb the sound waves, right? Like, that's a general way of saying it. I understand. But yeah, saying that's why submarines use sonar and not radar. I guess so. People probably like misheard it or something, and I think they thought I said that, you know, like sound, like radar is akin to like sound or something. But yeah, people got confused from that one, so I probably won't use that one again. Das did help you with rewording it. Yeah, I remember that part. Yeah. It was a little too general. That was a little too general of an analogy. I'll come up with a better one. Yeah, they really didn't, dude. I was watching some guy in the chat. He's like, "This guy has no idea. This EJ sucks." Blah blah. He kept going with it for like the next 15 minutes. And like, once again, when that happens, I try to think like, okay, did I misspeak? Did I misspeak, or was the analogy not good enough? And it was too general. It was too general of an association, that's all. But yeah, that guy, dude, guy wouldn't let it go. I'm like, wow, you're still talking. All right. You're watching here anyways, Mike? Yeah, right on, man. Thank you. I generally don't pay any attention to the chat on YouTube. Yeah, Mike, I'm doing it for 10 years. It's hard for me not to. But yeah, you can't focus on the haters, dude. Can't do that. I'm just not used to a chat going that berserk. You know what I mean? Like, not berserk like people were all like, oh, EJ's an idiot. Just that chat's wild. It goes so fast. It's really, really difficult to keep up with, you know? But on the flip side of that, fellas, I like listening to feedback. That's why I don't mind people actually me like every 5 minutes. I don't it gets annoying after a while, but it's you know, it's not a pride thing with me. You got to get the information right. The problem is recalling specific subsets of information off the top of your head over the duration of an 8-hour stream is really tough. That's really hard to do and get it right every time. You're gonna get one wrong, and I understand that, so it's all good. Yeah, Core, that's right. They don't buffer it. Constructive Kajiki. So, like, I kind of look to see, like, drummer, if people say, oh, that analogy sucks. Like, I would really like if they said why, but you're not going to say why. It's kind of up to me to go and figure it out, you know? Yeah, exactly, Joe. I just take it in stride. It's just feedback. It's just data that needs to be analyzed, man. That's how I look at it. You're part of the team, not just another number. TK421, why aren't you at your post? TK421, do you copy? I'll figure out a better one, Signer. You guys don't mind that one either. Like, I've told the submarine explanation many times, like how they spray the pads with water because sound likes to get absorbed by water. That's why submarines use sonar, because you can hear stuff through water for very long distances. Right? But I understand that's a very general way of looking at it. It's not absorbing water. Sound carries through water. I understand, but yeah, it was too general for YouTube chat. I gotta be a little bit, I gotta bump up the technicality, which is not something that I usually have to do, but hey. Maybe ask the other fellow STEM educator NSF guys for a better analogy perhaps in the future. Well, I'm the subject matter expert, drummer. Coming up with the analogies is, in that regard, would be like delegating my job to, you know what I mean? Like that's what my job is there for. I usually have to kind of be more general and less specific, but in this particular case, it's more specific, less general, which is very interesting. Yeah. But either way, I like the chaos. The chaos is fun. That chat's a freaking ride, man. It's crazy. How stupid much energy takes water to turn to steam. Yeah. Water when turning to steam also generates white noise, good for sound suppression. Yep. Anyway, it's good space news. Yeah, that was the Starship test, and I did cover it on NASA Spaceflight yesterday, and man, was it fun. It was a fun time. It was fun. I really enjoyed it. I thought the changes in medium was what blocks the sound. The sound is forced to go through the water, air, water. I'll delegate that one to Chat O-Force. Anybody in chat? Can anybody in chat help O-Force out? I gotta go read. I have to go read RPE. Because now I'm not sure about that explanation, so I'm... So you focus more on the water-steam energy relationship and you'll be golden. Yeah, we'll be all right. Yeah, the book. RPE has a good segment on sound suppressors and pad deluge systems, which are, believe it or not, two different things. Sound suppressors for the sound. Pad deluge is to basically quench the exhaust. That's the difference. Sound suppressors are above the rocket deck, usually, right? And pad deluges are below into the flame bucket. Now, keep in mind there are post-flame trench sound suppressors that are also designed to suppress sound. Like on Slick 40 and Slick 41, they have a sound suppressor that's technically down the flame trench. It's at the end of the flame trench that sprays into the flame trench. That is also a sound suppressor, but that's not a pad deluge. Interesting, right? It usually denotes where that water is being sprayed denotes the difference. Hey, Adam. 62-month resub. That part I do remember, but I have to go brush up on RPE again. Water absorbs kinetic energy. Bullets do not travel very far through water. Yeah? Adam, what's up, dude? 62-month resub. Does SLS have a pad deluge system? Yep. SLS has the sound suppressors in the form of the Rainbirds on the mobile launcher, but they also have a pad deluge that's in the flame bucket down in the flame trench. It's actually at the top, and it sprays into the flame trench. It's at the top of the flame diverter. It sprays into the flame trench. Oh, good man. Curious to see the Rakers' progress. Yeah, we'll switch back over. I think that was a pretty dang good space news. Yeah. That's all I got for you today. Let's jump back into KSP, shall we? So, actually, you know what? I'll check right before we do. I was about to say, let's check when the next rocket launch is. Turns out that the next rocket launch is in 7 hours. There's a Starlink going out of Vandenberg at 11:57 p.m. Go figure. I miss stretch breaks. Yeah, Signer, like I said, I got to be a little more technical with that explanation, but I'll work on it for next time. It's another Starlink! Another chair! There goes your sleep schedule. It's getting better. 15 V2 minis, Thomas. So what's the details on that Starlink? Let's check over on next space flight. So we have Starlink 620 out of Vandenberg. Right? That's sort of Vandenberg. Yep. Slick 4 out of Vandenberg. Batch of V2 minis. Payload's 15, going to low Earth orbit. This is Booster 1075, Flight 5, landing on Of Course I Still Love You after a 47-day turnaround. This is the 120th orbital launch attempt. It's SpaceX's 54th mission of 2023. Oh my God. Do it. Yeah, okay, never mind. Could you please put put the specific Starlink group in the title? Yeah, I'll start doing that, drummer. Yeah, that's fair. All right. Anyway, back to the Star Raker build. Let's